Hello and welcome to the Unreal Engine training stream live from Epic HQ. I'm your host today, Zach Parrish, and today we're going to be talking about blueprint communication. So we got a lot to cover today. I'm going to give a couple of really general disclaimers. One, this might run a little bit long. I'm going to try to keep it around the 90-minute mark, but that's me just spitballing. I have no idea how long this is going to take. If you're new to this or you're really interested in the topic of blueprint communication, I expect you to be taking notes because there's a lot of information we have to cover, so much so that I'm doing something that I generally don't do. I have actually made a slide deck that we're going to be reviewing as we go through all this. On that note, before we even get started, if we can take a look at the screen real quick, if you all jump over to unrealengine.com/resources. I'm supposed to be on the other monitor, I suppose. Let's just use that monitor instead. It'll be great. So at unrealengine.com/resources, you can find the slides that I will be going through today. So if you grab those, you'll probably get to take maybe half as many notes, but you should still be ready to write some stuff down. Again, there's a lot of stuff to cover here. So with that out of the way, let's go ahead and get started. I will just swap out the monitor that I'm doing important things on, and we'll do important things on this monitor instead, which will be great. Let's see, I'll hit the mighty present button, and now things look all kinds of official. Look at this, blueprint communication and you, complete with disco lights, because that's amazing. Okay, so yeah, I'm not gonna just read everything to you verbatim. I'm expecting you to kind of look at what's on the screen and read it, and I'm gonna kind of talk through it. In between each section, we'll pause and take a little bit of Q&A after a brief demonstration, and then we'll do a great big wrap-up Q&A at the very end. So, for starters, what is blueprint communication? Well, hang on, let me just click the allow button and get that out of here. So blueprint communication, I want you to just think of it as a way to get two objects to interact, to communicate in some form or fashion. So the classic example is a light blueprint and a light switch, or even a character and a light switch for that matter. And how do you get those two blueprints to send data back and forth to one another? It's useful for things like telling an object to do something, which is generally by way of sending an event or calling a function. Also useful for querying. So things like the status of something, its state, a property or a variable, or getting back any kind of results. Now, I did have a programmer point out to me that property values and variable values are the same thing. I only separated them because there are properties that exist on an object without variables, and if you're totally new to the world of scripting, it's probably useful for you to know that sort of thing. Now, a simple primer, stuff you should just know. Unreal Engine 4 has no way to just send a single broad signal out to everyone. There's no way that you can just say like, all right, something happens and anybody can just magically pick up that signal and just go from there. This was a thing, this did exist way back in the Unreal Engine 2 days, but it wasn't great, we don't do it that way anymore. Communication is always going to involve some blueprint that is sending and one that is receiving. You're gonna hear me use that a lot today. I'm going to call them the sender and the receiver. There's a lot of different words you may end up hearing as you do this kind of thing. You might hear things like instigator, which I didn't want to use because it gets kind of overloaded, sort of, kind of. So I'm going to keep things fairly simple. There is a blueprint that is responsible for driving the communication, which we'll call the sender, and one that is receiving that communication. And it gets a little interesting, and we'll explore why it's interesting as we roll forward. Now, communication is always going to require a reference at some point. So in other words, that means one of those two parties, the sender or the receiver, has to know about the other one. So this is going to be probably your trickiest thing when you first get started. How do you get that initial reference? How does Blueprint A even know about Blueprint B so that he can communicate with it, or she can communicate with it? We're not trying to pick a specific gender here. Now, this is because, as stated above, the reason you need these references is because there is no broad spectrum communication. Again, you can't just shout out into the world and expect random things to hear your message. There has to be some specific way of saying, you, I'm talking to you, and I want you to do something. Now, next key point. All blueprint communication is technically speaking one way. Now this will confuse a couple of people, but I want you to stop and think about it for just a minute. So blueprints can actually send data back and forth, but it's going to require both blueprints to set up their own individual paths of communication. Now, what do I mean by this? Well, you have a sender and you have a receiver. Sender to receiver is always monodirectional. Now, here's where it starts to get complicated. A sender can get a return value from the receiver. So for instance, if you're sitting across the room from me, I can be like, hey, tell me how old you are. And you just send back that information. Well, in Blueprint terms, that's like I just called a function on you, and the return value was you telling me that age number. So I get some data back, but I still had to start the process. I had to reach over and give you some sort of a command, and that's how Blueprint communication works. Now, beyond that return value, if you had something else you wanted to communicate to me, at that point you become the sender, and you would have to send me some data or make a request from me that I could send back as a return value. So it will help as you get deeper into Blueprint communication if you remember that, generally speaking, it's a one-way street, aside from things like return values. Okay, now, of course, in that way, queries are possible, ties into return values, but are still initiated by the sender, which I kind of covered. Now, for today and for our purposes, there are three primary Blueprint communication methods. We have direct communication, which we're going to be talking a lot about casting to make that possible. So if you've heard that word a few times, you'll know where that's going to tie in. We have Blueprint interface message calls, and we have event dispatchers. There may be some other types out there in the world, but in most cases, they're probably going to be extensions of one of these three types. So these are the three that we're going to be focusing on today. Now, since there are different types, how do you know what kind you can use? Now, if you're totally new to Blueprint communication, this part is probably going to make you curious. It'll bring up more questions than it does answers. So this is one of those things where the newer you are, the more this is kind of like seed planting. I just want you to hear this and think about it so that later on, once you're more used to Blueprint communication, be like, oh, I finally get what Zach was talking about when he carried on and on about when to use the different types. So what I've done is I've tried to simplify this into two key questions. And if anybody wants to come back and say there's a whole bunch of different things to consider, you're probably right. I was trying to keep this simple. So the first question is, what is the flow of communication? Is the sender pushing some data out to a receiver? And if it is, it's something like maybe setting a value on the receiver, or even just calling a function on the receiver. In that case, the sender is doing something and it's being received. In those cases, you'll be using either direct communication or interface communication. And there's another layer to figure out which of those two, but we'll talk about that later. Now, the other side of that, in terms of the flow of communication, is, are the receivers actively listening for their sender to do something? So in this case, the receiver is doing a little bit more of the heavy lifting. And if that's the case, you're going to be using event dispatchers. Again, if the idea of if conceptualizing the flow of communication is a little confusing right now, don't worry, go with it. It'll become clearer as we kind of go through this. Next, our second question is, which party can get a reference to the other? Remember earlier we said that Blueprint communication always requires one party, the sender or the receiver, to get access to the other. So if the sender has a reference to the receiver, then you're either using direct communication or you're using Blueprint interfaces. If only the receivers can get a reference to the sender, then you're using event dispatchers. And it becomes easier to answer these questions as you get deeper and deeper into Blueprint communication. So if you grab the slide deck and you're just following along, put a check mark on it, just grab a magic marker and right there on your monitors, put a checkbox. It works great with PowerPoint, and then you can come back and look at the slide later when you need it. So with that out of the way, that's our primer, okay? We won't worry about questions right now. We're going to talk a little bit about direct Blueprint communication, and then we'll answer questions just about that. Then we'll talk about interfaces and do questions just over that. And then we'll do event dispatchers and then questions over that. And then we'll have a great big wrap up if you have any remaining questions. So let's focus on direct Blueprint communication. High level concept. This is just one blueprint talking directly to another. A sender will gain access to a receiver. It gets that reference, that critical reference that you have to have. The sender can then query data and variables. It can say, hey, how old are you? What's your health? How much armor do you have before we can start actually chiseling away at your health bar, etc. It can send data and it can update variables. So one blueprint can say to another, hey, I'm going to set your health back to 100% because you just picked up this health potion or something. Or it could call functionality on the receiver. It could say, hey, I'm forcing you to jump because you just landed on a springboard or something like that. Now, this is always one-to-one communication and not one-to-many. This is just one blueprint talking to one blueprint, and that is all, and that is all it'll ever be. Now, you can use tricks of flow control in order to talk to a lot of different things. Like you could use a loop, for example. You could say, hey, loop through this n number of blueprints, this 152 blueprints, and for each one, send them this signal. But each iteration of that loop is still one-to-one. Now, there are some one-to-many examples for communication. We'll talk a bit about that with event dispatchers, but that's a different thing. Next, direct blueprint communication and when to use it. You're only going to use direct blueprint comms when you know the following. You know what the sending object is going to be. You know what the receiving object or objects are going to be. Or you at least have a clear way to get a reference to them. For example, like maybe grabbing an overlap or using the get player pawn node to get a reference to the player, that sort of thing. You know what data or functionality you're going to tap into. You already know that variable name or property name. You know everything, essentially. You know what's going to happen. You know who it's going to happen between. You just need to know when it needs to happen. You need to drive that. If you don't know everything, say like you don't know what blueprint is going to be the sender, or maybe you don't know what's going to be the receiver, or you don't know what property you're going to be talking to, then you will probably wind up, at least in terms of direct blueprint communication, in having to tie in a lot of if statements, right? Or branches, as they're called in blueprint. You'd have to do something like, well, if I tried to interact with a box, then open the box. If I tried to interact with a light, then toggle the light. This is generally not good, so if you find yourself doing a lot of nested if statements for communication, you should probably be using a different form of communication. Now, this also ties into casting, which we will talk about in a few minutes. But in short, and so you will have at least heard this a little bit as we go forward, casting is just a way to verify who you're talking to. So if you're doing something like, was this a door? Yes or no, and then do something. Or was this a light? Yes or no, and do something. Then if you're having to dig through and ask those kind of questions over and over again, you probably shouldn't be using direct blueprint communication. Just keep that in mind. Next, direct blueprint communication in action. How does it actually work? Well, the sender is going to get a reference to the receiver. There are so many ways to do this that I could kill the rest of my day just explaining them all to you, but some examples you'll run into pretty frequently are things that are assigned. Oh, there's lightning. That's amazing. So we can assign a reference at the beginning of the game, like say on begin play, we could get a reference to some actor and just assign it somewhere. You could do it on overlap. So for example, the character walks up to something, and that something has a volume in front of it that gives you an overlap. Because there was an overlap, you now have a reference to the character because he just walked into it, and now you can start doing things. Or you can do the very scary, and I tend not to encourage this, you can do the get all objects or actors of class. I see a lot of folks who are very new with Blueprint using this. I don't recommend that you use it, but it is there, and so every once in a while you may find yourself having to fall back on it. Just remember, that can be very slow, especially if you have a lot of objects in your scene. It's just worth mentioning. So once you have that reference, the sender may need to cast this reference to the thing it wants to talk to. And if you're totally new to casting, or if you think casting is some sort of dark programmery magic that is all kinds of scary, fear not, casting is actually very easy. We're going to make it pretty simple before the day's out. It's just a way to test and verify what you're talking to. If you need to send a message to your best friend Bob, and you just pick up the telephone and somebody is on the other end of the telephone, what's the first thing you're going to do? You're not going to deliver your message. You're going to be like, hey, is this Bob? And once that comes back with yes, then you'll deliver your message. Casting is exactly the same thing. It's just a way for you to make sure you're talking to the right thing before you start trying to communicate with it and do all the fun stuff you want to do. And we'll cover casting in much more depth a bit down the road. Now, if that cast is successful, then the connection is complete and you are ready to begin communicating. So the sender can now send data, it can pull data or query data from the receiver, and it can call functionality directly on the receiver. Now here's generally what casting looks like from the sender's perspective. You'll have an incoming execution wire. It's going to hit the cast node. Here's your reference. This reference variable could be populated from anything. Like, for example, it could have been populated because of some overlap further up the chain. And then we have a wire that goes out if the cast succeeds, and one that goes out if it fails. And then here is the data wire, which is, this is going to give us access to the functionality for whatever it is we cast to. And we're going to see this live here in just a couple of minutes. Now, before I do, this is where, if you're totally new to casting, I hope you were listening earlier and you brought a notebook or something that you can follow along with. So casting, I find, confuses a lot of non-coder types. Programmers are a little more used to it because casting is a programming term. So if you've been writing code, you're almost certainly used to this concept. As I mentioned earlier, just think of casting as a way to verify what you're talking to. Once you've cast to a given type, only then do you have access to it. Only then can you talk to it, and you can ask it things, and you can tell it things, and you can call functionality on it. If a cast fails, you can always cast to something else. So we get a reference to some actor or object, and then we say, was it a door? No. All right, well, cast it to a light. Was that successful? No. All right, well, was it a weasel? And then if that was successful, then yeah, we can do something to the weasel, like set its wearing party hat boolean to true, or whatever. Now, again, if you find yourself having to do these sort of nested behaviors really, really deeply, like you're asking 20 questions before you get to do anything, you should probably rethink how you're communicating, but it's good to know that you have that option. Now, if you already have a reference of the proper type, then you do not need to cast. What do I mean by that? If you knew when you walked up to a door that you had a door, and so you populated a variable in your blueprint of type door, then you don't actually need to cast it. In fact, when you try, Blueprint will warn you and say, hey, this was a door when you got here, so this cast is always going to return true, in which case you can just snip out the cast. But it is just a warning, it's not an error, so just be sure you compile, and Blueprint will do its best to tell you when you're overcasting. Overcasting, that's awesome. Okay, now, next. Casting and object orientation. Here's the fun bit of my job, right? So I travel the world, I go all over the place, and I help folks understand how all the different systems in Unreal Engine work, primarily the ones inside the editor. I'm still not the world's strongest programmer by a very, very long shot, but I talk to people a lot about Blueprint. And Blueprint, since day one, has been marketed as scripting for the non-scripter and non-coder like people. It is visual and it appeals to visual people, and all of that is true and all of that is super valid, but there's more to it than that. And the other side of it is that in order to really use it, you've got to be thinking a little bit like a programmer. You don't have to be a programmer, but you have to know some key programming concepts, and one of those is object orientation. The reason for that is that the Unreal Engine itself is built on an object-oriented framework, and you're going to be using that framework to make your games, most likely, 99 times out of 100. In fact, if you're just using Blueprint, you have to use that framework, so you need to know how object orientation works. So, on the left-hand side, consider the following class hierarchy. Now, I've indented the names wherever it denotes inheritance, right? And you might have seen a hierarchy like this before, even inside the engine. You have object, and actor, and pawn, and character. And then underneath that, we have 4 different playable characters that you could maybe possess and drive around your level. We have Wendy, Michael, John, and Peter, okay? Now, think about this from a casting perspective. This goes over to the data I've written down on the right. Casting to Wendy will give you access to the things that are specific to Wendy. So maybe things like, what is her nightgown color? Because obviously she was sleeping when Peter flew in through the window, but that's a whole other story. However, if you cast to Wendy as part of your blueprint, you can't access things that are specific to Michael, John, or Peter. Like you can't ask Michael what kind of top hat he was wearing, or Peter what color his dagger was. You don't know these kinds of things because you've cast all the way down to Wendy. Now, if you needed to access something that was available to all possessable characters, you would actually cast to the next class up. Like, let's say, for example, that all of these possessable characters, Wendy, Michael, John, and Peter, maybe they all have a pixie dust value for how much they can fly, right? Now, that would be something that existed on all of them, so you wouldn't want to set that up individually for Wendy and set it up again for Michael and set it up again for John and so forth. You would set that up in character, and that way they would all just inherit the value. So if you needed to query that value or change that value for any one of these characters, you wouldn't want to cast all the way down to them, you could just cast up to character. Now that's one of those things where if you're totally new to the world of programming, this can be a little confusing. So go bear with it. Take some notes on this, and then the more you get used to it, the more you start actually handling blueprint communication and casting, this will make a lot more sense. Now, continuing on, not all of these cast levels are guaranteed to give you access to the functionality you need. So if you cast way too high, like to a too high of a parent class, that's going to lock you out of specific functionality that only the children have. So for example, a character is going to have some sort of a physics state. Is it walking? Is it swimming? Is it jumping? And so forth. But if you cast up to actor, none of that stuff was implemented in actor. So you would have cast too high and you won't find the data you're looking for. On the other side of that though, casting too low down a way too far child class will lower the overall flexibility and eliminate the possibility of accessing sibling classes without further testing. So you have to think about this intelligently, and it ties into making sure that you are building your blueprint classes and keeping that class hierarchy in mind. Make sure that if you are creating several different types of objects, if they have to have common functionality, then it's possible they should have the same parent class and build up from there. Now, obviously, there's a lot to that, and that's one of those things where we're kind of getting a little bit onto side topics like the Unreal Engine framework and how to build classes of objects and child classes and so forth, but it all does tie together, and it's all super important for blueprint communication. Just keep that kind of thing in mind. Remember, shared concepts belong in higher base classes, and don't duplicate your work. If you find yourself taking a selection of nodes and copying them between sibling classes, you're probably doing it wrong. Go up to the parent class and put that functionality up in the parent. That way the children just inherit it. They get it for free. Okay, enough beating that dead literary character. So now demonstration. Let's demonstrate blueprint communication and direct comms, and then I'll take some questions. So let me bring the editor over. If you're following along or you're wanting to do this on your own, I am just using the third person blueprint level. So what we're going to do for starters is we are going to set up a really simple system to hurt the player, and we're not even going to use blueprint communication to do this. Mostly for academic purposes, we're going to show you how to take damage and apply that to the health of a character, so we have to set up health. Then we will create a blueprint that can communicate with our player, cast to it, and then affect one of its properties, specifically that health. So we're going to hurt him, and then we're going to heal him, and we're going to talk about how all of that works. So for starters, this is just preparation. I'm only showing this so you can follow along later. If I am moving too fast, don't worry about getting me to slow down. Just take notes, and then come back when we throw this up on YouTube and follow along at your leisure, because then you have a pause button, right? We're going to start by going under the placement mode. So over here in your modes panel, click on volumes and scroll all the way down to the bottom. And you want to grab a pain-causing volume. Boom, and you're just going to drag that into the world. Now, pain-causing volumes do not render in the game. You cannot see them. So we're going to put something on the ground to make it a little easier to see. Let's go over to basic, and we'll grab a cube. I'm just going to drag a cube right here onto the floor. And then I'm going to scale it down a little bit. I probably don't even need to scale it, but I did anyway. We're going to gently move this down so it's just sticking up out of the floor, and I'll scale it up so it fills in pretty much the floor space of our cube. Let's hit F to frame up on it so we can kind of see it. This does not have to be perfect, so if you're spending a lot of time getting it just right, you're probably overdoing it. And then let's go over to all classes. Let's type text render. And we'll drag this into the world, and it's always facing the direction I don't want it to face, which is fine. We'll rotate that 180 degrees around, and then 90 degrees back. We'll pick it up into the air so there's not all that crazy flickery Z fighting. And then let's give this some meaningful text. We'll just call this pain volume, or something like pain volume. I can't type, at least not from this far away. All right, that looks pretty good. And also because I'm just that kind of guy, we'll make it red. Sweet. Okay, cool. So now it's labeled and everything's good. Now, real quick, select your pain volume, and right now its damage per second is super low. Just set that up to 10. Now, quick fun fact. The engine, Unreal Engine, includes a setup for damage. In fact, we're looking at it. We have things like the pain-causing volume, which has its own damage type and so forth. What it doesn't have is an integrated idea of what health is. So damage is there, but you had to determine what that damage is actually going to do. So let's open up our blueprint folder. Let's go into the third-person character. We'll double-click that and bring them up. Let's just dock this all the way at the top so everybody can see. And I'm just going to get a nice blank area of the event graph. Now again, this is not really worried about blueprint communication right now. I'm just setting up a common test bay so you can follow along while we do all this stuff. I want you to right-click and type any damage. And you'll see there's an event here called event any damage. Boom, haha, and this takes in a certain amount of damage and it's gonna do some stuff to it. Well, again, we have no concept of health, so let's fix that. We have a variable here. Let's add our own custom variable. We'll call it health. And we'll take its type and we'll set it over to float, like so. Now let's compile. And you can set your default health to whatever. I'm gonna use a base of 100, right? Because that's pretty common among video games. So there we go. We have a base health of 100. Now let's control drag this into the graph so we get a reference to it. Let's take our health and hit the minus key to subtract. We'll say float minus float and we will remove whatever our damage type was. Next, let's take our health variable again. This time we will alt drag a copy into the world and we will use that to set the new value of health. And it's pretty easy to see what this is doing, right? When we have incoming damage, take our current amount of health, subtract away the damage and take the result of that, set it to our new value for health. So we are indeed steadily dying. Next, let's print that out to the screen so we can see something happen. So we'll just say print string. Now obviously, hence the name, this node takes in a string, that's why it's magenta. If you try to plug a green float into it, Unreal will pat you on the head, say that you don't understand how data types work, and it'll create a node to help you. Leave that there, it is to your benefit. Okay, so pretty easy to see how this works. Let's test it real fast. We'll compile, jump out to our map, and hit play. Here's our guy, he runs over, stands on the pad, and you can see his health steadily dropping 70, 60, 50, 40, and so on. Awesome. None of that was blueprint communication. Now let's fix that and let's do something where we have some blueprints communicating. For this, we need a blueprint. So down here in the content browser, we will right click and we will create a new blueprint class. We're gonna base this off of actor. Anything that can live in the level will be just fine for us. Click, and we'll call this the healing volume. Bam. Double click and open this guy up. And here we are. Now we're going to keep this really, really simple. We're going to start with just a box collision. And there it is. Let's just call it volume. We'll give it some kind of a meaningful name. And I'm going to jump over to its box extents and set this to 200 by 200 by 200. That gives it the same default size as that pain-causing volume from earlier. So that's the only reason we're using that. Next, let's go over to the event graph. Now we are going to cheat and make use of some of these events that are just sitting here waiting for you to do something to them. We have event actor begin overlap. So some other actor is overlapping with our blueprint and we have a reference to that. And there is the very heart of all blueprint communication. We have that reference. Now there's other ways we could do this that we're not going to do because it's not efficient, but we could do something like get player pawn. Boom, and there, as long as it was player 0, which is what it would be for a single player game, we would have access to some pawn class, but it's not necessarily the same class as our third person character blueprint. Just a really quick thing, if you go over to the third person character blueprint, or any blueprint for that matter, you can go to class settings at the very top and you can always see what that parent class is. So the parent class of this guy is actually character. Character is in fact a child class of pawn. So if I was to take our player pawn and drag a wire out from it and say, health, I don't even get anywhere with that. It's like, I don't know what health is. There's nothing we can do here. That's because this is the wrong class. We would have to cast this, but we could say cast to, let's just start here. Let's cast a character. Awesome, so now it's a character. Now let's type health. We still get nothing because we didn't implement health in the character. We implemented it in the third person character, which is a very special specific class. So let's drag a wire from this and we will cast to third person character. And now if we drag a wire off, we get access to health. Check it out, we can get health and we can set health. Mwahaha. Now, we don't really need the player pawn for this, so I'm gonna remove this node. And notice as soon as I do that, this guy actually grays out because this is a wildcard value. So we're just gonna take our other actor that came in from our overlap and plug that in. Now, what is this doing? This is saying, hey, that thing that overlapped with us, what was it? Let's make sure that it was a third-person character. And we need to hook this up to an execution pin. Cool, and once we've confirmed that it's a third-person character, let's set its health. Boom. And what are we going to set it up to? Well, we're going to set it up to 100. Now, we're hard coding that value. If I was being really hardcore about this, then we would have a separate value, a separate variable over inside of our third person character, probably called something like max health, and that would hold the maximum default health that our character has, and then as soon as we verified that it was the third person character, we would get that max health, and we would send that into the health value, but we're not going to do all that. That seems a little over the top for this example. I just want to mention it. So, this is all we're doing. Something overlaps, we make sure it's a third person character, we set its health to 100, everybody's happy, let's compile and save. Actually, one more thing, real quick. Let us print something to the screen. And I'll just put a custom message, say, character has been healed. Haha. And we will also take the color of this and set it up to green because that seems like a really healthy color. Awesome. So compile, save, jump out to the map, and let's get this guy into the world so we can start doing some stuff. So I'm going to take our healing volume and drag it in, and it looks like 200 by 200 by 200 was about twice as big as that really needed to be. So I'm just going to scale this down because size doesn't really matter. Chuckle, chuckle. And then once we've got this off to the side, let's just take our little floorboard that we put in here, and I'll actually, and our label as well. We'll just alt drag these over to the side so we have a version over here. Let's take our text and we will set this to healing volume. And we'll set the color to something nice and friendly and green. Awesome, so now we can test this out. Let's hit play. And we run over and, haha, 90, 80, 70, 60, 50, and so forth. Now we hit the healing volume. The character's been healed! Awesome, so now let's run back over and get hurt again. 90, 80, 70, and so forth. So we did actually heal the character. So that is direct blueprint communication. And how did it work? Just one more time. Let's review before we move on. We have our blueprint, and it gets a reference to a receiving object. It casts to make sure that that is exactly what it wants to talk to. Once it has finished up that cast and that cast has succeeded, we now have access to all the properties on that object. We're going to set them to something else. We're going to send it some data, and then we're just going to do our own thing and print some magic out to the screen. That's it. But we could only do this because we knew who the sender was going to be. It was going to be this volume. We knew who the receiver was going to be. We knew it was going to be the player character. And we knew what data we were going to send. We knew we were talking to the health value and sending it some number. If we didn't know all those things, we'd have to start asking a lot of questions. It would be like, hey, cast this to the third person character, or even just cast to a regular character. Was that successful? Yes or no? All right, was it the third person character? Yes or no? Does it have health? Yes or no? You'd have to start asking all these questions before you began communication. So, with that, there is our simple example of direct communication. So, let's jump back over here. Are there any questions about all of this? And to kind of help all of that, I've got some stuff over here. So, now, some of the questions that I'm seeing pop up in our little list O questions are for a little bit later down the road. So, if I know we're going to talk about it later, I'm not going to worry about it right now. How can we use the inherit classes between BP classes? I really wish I could just reach the screen and get you to rephrase that question because I'm not sure what you mean. In order to inherit functionality from one blueprint to another, you simply need to make a child class. So for example, let's say I needed a different kind of healing volume that didn't actually heal you up to 100%. Maybe it only healed you down to, or maybe it overhealed you. Maybe it healed you up to like 150. That'd be pretty cool, right? But it could have the same basic functionality. I could just right click and make a child blueprint. So now this is a healing volume child. Let's call it super healing volume with a W at the end because it's stylish. The W's silent. Let's go to the event graph and notice, check it out. Event actor begin overlap has a call to the parent. So this is all of the functionality that the parent class was doing. So we could override this if we wanted to. We could snip this and add our own functionality, so which would be essentially overriding, or we could add further functionality beyond this. We could maybe grab the character and add more health. We could call any other functionality on the character that we wanted. But the point is, because this is a child class, everything that our parent can do, we can do too. Every single variable that we have, the child has as well. So I hope that helps that question. If it comes back up, just ask again in a slightly different way, and we'll drill a little deeper. Let's see. You got to give me a second to kind of read some of these questions off to make sure that they fit in with what we're talking. Question: why is there a pane volume? Wouldn't a general volume with customizable functionality be enough? Sure it would. It's just a convenience thing. It's one of those little quality of life things. It turns out in a lot of games you're going to want to cause damage to something. But I actually agree with the spirit of where your question's coming from, right? Because why do you have pain causing and you don't have health on your default character class? It's just the way it is. So if I had to answer your question, I guess most directly, it's kind of a legacy thing, because we've always had something like a pain or a damage volume or a physics volume that cause damage. In fact, I think you can just take a physics volume and have it cause damage if you want to. I'll be the first to admit I pretty much never use pain-causing volumes when I'm working. I just threw one out here because it was kind of handy and nifty. And it's cool to know that the idea of damage lives in the engine, but the idea of health does not. While that may be a tiny little bit on the counterintuitive side, it's good artillery for you to have in the back of your head. So if you're like, well, how do I implement a damage system in my game? Look into it, because you might not have to. Okay, so I'm just going to highlight the questions that I've already... Actually, maybe Alexander can highlight the questions that we've already addressed so that I don't have to actually do that. Without any other questions popping in, let's just continue. Anything else that pops in from here on, we'll just address toward the end of our discussion. Which brings us on to our next topic, and that is blueprint interfaces. Now, blueprint interfaces are a way that we can specify functionality without any kind of implementation. So this is just a concept. This is how and why they work. We're going to get into how to actually use them as we roll forward, right? So a way to, okay, we covered that. So an example of a blueprint interface in the real world would be when you tell two different people to go get their favorite food, right? And person one is like, well, my favorite food is homemade pizza, so I'm gonna make my own homemade pizza with all this awesome stuff on it. Person two is like, you know, my favorite thing in the world is Chinese takeout. So he gets on the phone, calls up some takeout, and goes and picks it up. These two folks did two really different things. They produced really two different activities, but you gave them both the same command. Now, the nice thing about that is that interfaces don't really care whether or not the receiving object knows about them, knows what to do with them, if the receiving object is even capable of doing anything with them. So imagine a third person that is a robot and doesn't eat. So you tell them, hey, go get your favorite food, and they just kind of stare at you and their little eyes for their lights just blink a couple times because they have no idea what to do with that command. That's okay, your game won't crash. So when you know you want to send a signal out to something, and you don't really care what that thing does, you just want it to do something, then blueprint interfaces are probably the way you want to go. Now, interfaces are still one-to-one communication. You're going to get a reference. You're going to send a message to that reference. You could still use loops in order to make them one-to-many, but each iteration of that loop is a one-to-one level of communication. And then the sender is still going to need some reference to the receiver. It's not just a blank signal being tossed out into the world. You have to get that initial reference, and that reference is going to drive who it is you're actually communicating to. Now, how do interfaces work? Interfaces are a unique form of communication because they are their own Unreal asset. You will start by making an interface in the content browser, which we will demonstrate later. You're going to send data called an interface message through that asset and out to any of the listening objects. Now, by default, nothing receives an interface message. So if you build a blueprint interface and you send a message out through it, nothing by default will receive what you just sent out. You must implement the blueprint interface onto any blueprints that are intended to receive. And unless you do this, that blueprint interface does nothing. So think of a blueprint interface kind of like just a piece of wire. You have a switch and you have a light bulb, but you gotta have a piece of wire that connects in between the two or nothing's gonna happen. That blueprint interface is gonna be your wire. Now, this means that anything that doesn't need to respond to an interface message simply doesn't have to implement the interface. So for example, I've got a switch here on my desk that I could flip, and I don't want it to affect the laptop over on the other desk. That's fine. I don't have to run a wire to the laptop, and then I can just throw the switch all day and it does nothing over there. If you have objects that don't need to respond to an interface, simply don't implement the interface and everything will be just fine. The nice thing about this is you can still send signals out through the interface, and if nothing implements them, then nothing will happen. It doesn't mean you'll have any errors, nothing will crash in your game, and you can just keep moving forward. Next, it is perfectly safe to send interface messages to objects that don't implement the appropriate Blueprint interface. Now, this is kind of what I just said a moment ago. So if you haven't implemented the interface, nothing will happen. It'll just silently fail and continue. You should know about this, because if you have set up some important behavior between two blueprints involving an interface and you forgot to implement, then nothing will happen. And one of the first things you should double check is, hey, did I actually implement the interface? Did I implement it correctly? So make sure you know those sorts of things. Okay, when are you going to use Blueprint interfaces? When you are sending a signal to some other object and you don't really care what it does once it receives the signal. Or you don't even care if the receiver even knows about the signal. The receiver is almost completely unimportant to you right now. You're just going to send something out, and hopefully the thing at the far end knows what to do with it and responds in kind. If they don't, hey, no worries, then it's just an airball, it sails on past them, and everybody keeps right on playing. If you want to send a signal to an object and they do know what to do, they know to reach out and catch the ball and then try to run upfield, awesome, then it's just going to work. Here's an example in terms of games. I have an interaction. I'm going to hit the B button, and then we send out an interact with things signal. Doors magically know that they should open. Lights know that they should toggle on and off. Potted plants don't know anything, and they don't do anything, so they're not going to care that you're interacting with them. So in that case, we would implement the interface on the door, we would implement it on the light, we would not implement anything on the plant, and therefore nothing would happen. The point is the implementation, whatever happens, if it's a door opening or a light toggling, that's the receiver's problem, and you as the sender, you don't even care. Also, fun fact that we will explore, also, we're like really zoomed in on that PowerPoint right now.
I just like potted plants don't do anything.
Oh, okay, gotcha. I mean, we need like a highlight right there. So a quick fun fact. Interfaces can be used for communication between sublevels, which I will really quickly show off once we get to our actual demo. Because there's a lot of folks who ask about communicating with level blueprints. You can totally do it. You're just probably not going to do it so much with the persistent level. As a matter of fact, just to kind of plant this seed in the back of your head, if using level blueprint is something you really want, you're going to have a much easier life if you make a sub-level, even if that sub-level only exists to hold level blueprint and anything that would need to communicate with said level blueprint. Okay, moving along. Blueprint interfaces in action. So here's a quick practical rundown of how these are going to work. If you're watching the little tiny thing in the window, yeah, I have some notes to just keep me from going too far off the rails, so I'm making sure those are all keyed up. Blueprint interfaces, you're going to start by creating them in the content browser. You simply right-click, go to the Blueprint submenu, and click on Blueprint Interface. Then you give it a name, press Enter, and then in the Blueprint Interface Editor, you will automatically get your first interface function. You have to give it a name, and then you can start setting up things like inputs and outputs. Once you've done that, your next step is, now, just a quick note, as you're setting up the inputs and outputs, you will notice that you cannot set up any functionality. These are not like regular graphs. You can't throw more nodes into them, as we will see. So I'm not going to jump away and show you just yet. Then you will implement the interface on receiving classes. Any class that cares about and has to receive this message will implement the interface. It's important to note. The way you do this is go under class settings of the receiving blueprint. Under implemented interfaces, simply add your new interface. It's very, very easy. Just make sure you recompile when you're done. Until you recompile, that interface doesn't exist as far as the blueprint is concerned. If you screw that up and you try to set up blueprint communication through interfaces and you haven't recompiled, Unreal is generally pretty good about warning you. Just make sure you read the warning really, really clearly. So once you've done that, you can create an event in your graph, name the same thing as your function, and when this class receives the message for that interface function, something will happen in return. Now, note, as I said before, Receivers are the only thing that actually need to implement the interface. You don't have to worry about it in the sender because anybody can call an interface. Anything in your world can make a call out to an interface. Only receivers have to implement and therefore respond. From the earlier example, as I mentioned earlier, only the door and the light would implement an interface. The plant would not need to because the plant is just going to sit there and keep pumping out oxygen like they do. So, implementing interfaces by way of events. Here's a fun little quirk about Blueprint interfaces that we will see. I'll make sure to show it off. If you make an interface function that has a return value, it is implemented on the receiver as a function. If you make an interface function that has no return value, it is implemented as an event. If that sounds confusing, just sit on it for a minute and I'll show you how this works. But here's a quick visual example. So here is what the interface editor would look like when we're creating our interface for the very first time. And notice we have no return value. You can see that here, there's inputs, and trust me, if we could scroll down, we'd see there were no outputs as well. When we go to the sender and implement this, when we go into our event graph to send a call out to that interface, this is what it looks like. We are just sending something out. Now notice, we have an input. We're sending something out. We're just not worried about getting anything in return. So this just fires off like an event. On the receiver's side, this is what you get. You actually get an event that you can implement in your blueprint, right? So it starts here. This is what the sender sees. And this is what the receiver sees. The receiver will get an event that they can tie all sorts of stuff to. So all I was doing here is our sender is just making a call to the interface message and sending out a Boolean. And then our receiver gets that Boolean and does some stuff. In this case, it's just deciding to yell true or false at your screen. Now on the other side of this, if when you are setting up your interface, you have a function, if you have an output value, then on the far side, this will get implemented as a function and not as an event. And if you don't know the difference between events and functions, I'll show you the difference, but it's possible you need to do a little bit more homework because there's a remedial level of Blueprint knowledge you need to make sure you're super comfortable with before you can make the most of all of this info. So if, again, here it is just written out for you. If you have an output, it's going to be a function and not an event. And this is what you're going to see on the receiver. So there's what you'll see in the interface editor. What you will see on the sender is very similar to this image, but there will be a little return value down here on the lower right-hand corner of the node. And then you will just get a function that you will have to set up in some way on the receiver. Okay, and this is a little bit more what that's going to look like on the sender, right? So you will call that function. You can send an input if you like, and then you'll get some sort of an output, like so, that you could then do something with. Okay, bonus trick. You can use an interface for self-calling functionality. So once an interface function has been implemented on the receiver, if you want to, there's no reason why the receiver can't also use that same interface to send messages to itself. So why would you ever want to do this? Well, if you know that you want to have a certain list of functionality on a set number of classes, and maybe for whatever reason, and this is a little academic, maybe those two objects cannot possibly exist in the same class hierarchy, then you could just implement the same interface on both of them, and you're going to have the functionality there. You just have to make sure and finish off the implementation. What's it going to do with the data? But the point is, since anybody can call an interface, they don't have to implement it to call it, but since anybody can do that, even somebody who has implemented the interface can call the interface on itself. So it's just, again, it's kind of a way to guarantee that a certain amount of functionality exists on a class. If that doesn't make sense to you, don't worry about it. Just remember that I said it, because it'll probably come to you on the bus. All right, so let's give a demonstration of Blueprint interfaces, and then we can go into a few questions about those, and then we'll move on from there. So meanwhile, back at the ranch, or back over in the Unreal Editor, where we left off a little while ago. Also, I might be dying a little bit over here, so with all the talking, I'm gonna crack open my magic bottle of water. Okay, a little bit less death. So let's make a couple of things that we can interact with. We're gonna set up a very basic interaction system that leverages Blueprint interfaces. and we'll talk to a couple of different things. So for starters, to set up your basic interaction, we need to expand the functionality of our default character that comes with this project. So I'm going to go up under Edit and go to Project Settings, and we'll jump right down to Inputs. And over in the Inputs, let's go to Action Mappings, and we're going to add a new action. Aha! And we will call this action Interact. Actually, let's call it Interact Button. I normally wouldn't do that. I normally wouldn't call it button. It's just going to keep things a little more clear as we move forward. And let's set this to, I generally like the E key. So let's do, let's see, if I hit E and space, I think it'll show up a little easier. There it is. Okay, and then let's do another one. This one will be query data. All right, and this I will tie to the F key. All right, so interact with E and query data with F. Now these are both going to be fairly generic, and we'll figure out what they do over inside of our character. Now next, let's build our interface. So now that we've set up our inputs, let's build an interface. We'll just right-click, as I mentioned earlier, we'll go under Blueprints, and there is Blueprint Interface. So we'll click that, and we'll give it a name. We'll call this I, lowercase I, and then Interactable. So I kind of like, this is just me, I like naming my interfaces using adjectives, so that as I apply them to an object, I can just look down the list of implemented interfaces and say, ah, this object is interactable, or it is damageable, or it is, I don't know, some other word that probably has able at the end of it. And I have the lowercase I at the front just as a brief reminder that this is in fact an interface in case I ever see it listed off somewhere and I'm like, wait a minute, what kind of object was that? Okay, so now let's double click this and open it up, and we get the interface editor, which automatically comes in with a function that is just sitting there. And we will call this new function interact, which is why I called the other one interact button, to help alleviate a tiny little bit of confusion. Now for this, we're not going to worry about any kind of input or output. We will, however, add another function. So we'll click on add new, go to function, and we will add this. And let's call this get interact state. All right. And this guy, he's going to at least have a return value. So to do that, we'll have him selected. We'll go down to outputs, which is what you do for a return. We'll click new, and that'll give us a Boolean, which is fine. We're going to name this interact state, which that screen is like 1.5 miles away, so I hope that's what that says. Actually, I can see it just fine, but there's something about using a monitor that is that far away, you just, it doesn't feel right. Okay, so we have our interface set up. It has two functions, interact, get interact state. One of these has no output value. The other one does, but notice in here our graph is completely grayed out and we cannot do anything with it. We can select nodes, but we can't move them. We can't add new nodes. If you try, Unreal kind of yells at you. I assume that bold font is yelling. It says, cannot create new nodes in read-only graph. And imagine if Unreal had a voice. That's pretty close to what it would sound like. So with that, let's go ahead, compile, we're done. So we can close this, we don't really need it. I might open it back up to look at things. We don't really need this guy either, and we don't need this guy. We will need the character, because that'll be the next thing that we work on. So we have our interface all set. What we need now is for our character to utilize this information, and that's why we set up the inputs at the beginning. So let's start off by right-clicking, and let's type interact, and we should find interact button. That is our action event. Let's create that. Let's also right-click one more time, and let's do, what do we call that? We said data, something or other. Yeah, there was query data, haha. So there's another action event for that as well. So we have these two different buttons. Now, for this, however, we need to have some sort of a reference. Remember, way, way, way early on, a long time ago in a galaxy far, far away, I mentioned that all Blueprint communication is going to take place by way of a reference. You have to have that reference. So that's what we're going to set up now. We're going to set up a very simple trace that will allow us to figure out what object we are trying to interact with. And I'm gonna jump over to this in my notes, not because I don't remember how to do it, but because I want to make sure I set it up the same way in my notes in case I ever have to hand these notes off to anybody else. I'm just covering myself. So here's what we're gonna do. We are going to do a trace, and a special kind of trace for this. Let's do a sphere trace. I thought about a capsule, I think, at one point, but that's not what we're gonna do. We'll do a sphere trace. And when you do this, there's by channel and for objects. So we're just gonna go by channel. Now, what is a trace? Real quick, for those of you who've never done one, a trace is just a line drawn through 3D space, and it is going to see if it hits anything. It's kind of like firing an instantaneous laser into the world, and if that laser hits anything, it's going to feed some data back. This is special because it's a sphere trace. It's not just going to shoot a laser. It's going to sweep a sphere through the world instantaneously, and then along that sweep distance, it'll say like, hey, did that sphere hit anything? If so, let's talk about it. Let's do some stuff to it. Okay, so first off, we need to figure out where this trace will start and end. So let's grab something that has a location in the world. I'm gonna grab our capsule component and we'll get a reference to that. So notice I just dragged that from my components window, and then we will say get world location. And this will be the beginning of our trace. We can just take this and plug it right into start. This is where everything will begin. Next, we're going to take our capsule component and we're going to get the forward vector. Basically, if you were to make a vector or a line from this capsule, what direction would that line be facing if it was pointed forward, the same direction the capsule was pointed? So it gives us that vector, which is pretty fancy when you think about it. Next, we are going to multiply this vector by a float value. And if you ever multiply any vector by a float, you're actually multiplying all three indices or all three components of that vector, and you're just increasing or decreasing, you're scaling the length of that vector. So we're gonna set this to 100. And because I don't like hard coding things, after I've set it, I'm gonna right click, promote it to a variable, and we'll call this trace length, because that's the length of our trace. By the way, just a really quick shortcut for those of you who didn't already know this, if you set a value first and then you promote it to a variable, its default value will be whatever you had hard-coded. So sometimes that can save you a couple of extra clicks. Okay, so now that we have all of this, we are going to take our get world location, so this is the location of our capsule. We are going to add to this, so vector plus vector, our forward vector that we've multiplied by our trace distance, and that will become the end. So what does this actually mean? All of these nodes are simply saying, I want you to sweep a sphere 100 units forward from our character's capsule. That's it. That's all we're doing. It's actually super basic. Then let's give this sphere a radius. We'll give it 50, and then again, if you just want to be hardcore about it, you can then promote that to a variable, and we'll call this trace radius. Cool. All right, so we've got that. It's all good, and it's done. Now, we need to do some things with whatever it is we hit. So this is how we get our reference. We take this out hit. Now this output is a struct. A struct is just a culmination of a whole lot of data. It's like a bucket full of a whole bunch of different kinds of data. If you right click on this guy, you can split off the struct pin and you'll see all these different things. One of them is the out hit actor. So that is the out hit actor. This is the actor that we actually struck with our trace. So let's, we could do this in a couple of different ways, right? We could just call our message on this. In fact, note, we have done nothing with our interface on the character itself. There's been no implementation, no discussion of implementation, but we can still type interact and check it out. Under class iInteractable, you'll see interact message. That is how we send data out. That is how that works. So we could just do this, but I'm going to take it one step further. We don't know if this trace ever actually hit anything. And it would be nice to not call this message if it turns out the trace hit nothing. So what we'll do is a quick isValid test. Now you'll notice there's two of these. There's an isValid function and an isValid with a question mark. And you don't see that very often. We want the one with a question mark. So this is kind of like a quick branch statement. It's saying, take an incoming object, and if it's valid, meaning it didn't come up as null or nothing, it means we actually hit something, Then we want to call interact on whatever that object was. We sent that out by way of an interface message. Then finally, let's just take our interact button and we'll connect this to our sphere trace. That's it. And I'm going to try my very best to give you a nice full screen view of that so that if you really wanted to, you could take a screenshot of this and save it somewhere. So there you go. That is all we're doing right there. That is the whole kit and the whole caboodle. All right. So we're not going to bother testing that right now. We can't actually. The only thing we can do is we could set the debug type to duration, and we could compile and jump out here to our level, and we could hit play. And if we hit E, you can just barely see it. I don't know how well it shows up on the camera. You can see there's a little capsule that appears in front of our character, and however the character turns, it always shoots out from his forward direction. And if I spam the button over and over again, it gets darker and darker, so it's a little easier to see. Now, if that trace hits something, you'll get a little green version of the capsule, like so. So cool, the trace is working, but right now we have nothing with which to interact, so now let's focus on that next. I'll tell you what, hang on, let me redact that real quick. We've already implemented the interact button. Let's also take a minute and set up how query data is going to work. As a quick reminder, because I've been talking for a minute, if we jump back over to our iInteractable interface, we have our interact function and we have our getInteractState function that has a return value. So let's make sure that the character is ready to do something with both of these. Now here's the deal. This is going to work in very much the same way. We're just going to send out some kind of a trace, but we're going to call a different interface message. And here's the thing. If you ever find yourself reusing script, it's super easy in Blueprint to be like, all right, man, I'm just going to take these nodes right here. I'm going to hit Control-C, and I'm going to hit Control-V, and most of the work is already done, man. I didn't have to create all that stuff over and over again. Great. Awesome. No, that's perfect. You did a great job just then. The problem is now, what if you decide you wanted a different kind of trace? What if you wanted a capsule trace or a box trace or something else entirely? Then what do? Well, you have to go fix it here, and then you have to go fix it here, and that gets a little bit of a headache. And I don't want to do that much work, and you probably don't want to do that much work either. Be lazy when you can be lazy. So what we'll do instead is we're going to grab everything outside of our event and all the way up to our interface, but not including the interface message, just leave that alone. And we're going to right click, and we're going to make this a macro. Now, as you might have heard me yell about before in other training videos, you have some options here. We could just collapse this to nodes. We can make a function or we can make a macro. If we collapse it to nodes, we have to copy paste it, and each copy is its own individual collection of those nodes. That's not useful because that still means we have to go fix all different copies if we break something. Making it a function would pretty much be valid, like that would work, but try to reserve a function for only those times when external objects need to call and reference that functionality. Basically, is there another object that lives in the world that needs to call this trace? If so, consider a function. If not, consider a macro. What a macro is a way to collapse all those nodes down to a single node, and then you can make as many copy-pastes of that one node as you want. And if you broke something, or you screwed it up, you did the wrong thing, you can jump into any one of them, you can fix that one copy, and it automatically fixes it everywhere else, and you get that fine opportunity to be lazy and still get a good day's work done. It's also called being efficient, so don't over-iterate on being lazy. So we'll collapse this down to a macro, haha, and let's call this trace for interaction. That sounds like a really useful name. And now our graph looks really cool and really fancy, but it has these mind-numbing crossed wires, and I don't really have any sort of OCD problem with that, but I'm gonna fix it anyway, right? So you guys have my back on that one. If we double-click that trace for interaction macro, step down inside of it, we can click on the output or input node, and over here in the details panel, you'll see all the outputs and all the inputs listed. Simply come over here to your outputs, expand either one of these, and you'll have a little up or down arrow. Just click up, and that reorders those. So isValid's on top, out actors on the bottom, compile, jump back out of your event graph, and now things are entangled. And our graph looks super neat and nice and tidy. And if your friends open up your blueprints, you're like, wow, how'd you do so much magic in one little node? And you can feel fancy. The other nice side of this now is that in order to set up our query data, here's all we have to do. We can grab our trace for interaction, hit Control C, hit Control V, plug that in. Aha! And then simply drag a wire out, and this time we're going to call query data. What do we call it? Did we call it? What did I call that? Good Lord. Pretty sure I called it query data. No, I called it get interact state. Oh well, that's fine. So we'll drag a wire out. We'll say get interact state. I called the button query data. That's why I was reading that. So boom, there we go, and that's just gonna work. But this also gives us a return value. So while we're at it, why don't we take that return value and let's print it out to the screen. This is just under the assumption that you wanna do something with this data. And we'll connect these up. Unreal will convert it for us, so we have even less work to do. And there we go, we're done. So we've done the implementation side of our interface from the sender side. Notice that didn't really require anything but making calls to those interface messages. And notice they got the cute little envelope icon on them just to show that they're interface messages. You're sending a nice packet out to somebody. Cool, done, awesome. Now, with all that out of the way, and I know time is just ticking on by, and I warned you this would probably be a little bit of a long discussion, let's build some things that we can interact with. Once again, I'm just referring to my notes so that I do this in a way that is reproducible on the far side. Let's begin by making a really simple door. Now, I'm totally going to cheat. I know there were some people earlier today on the forums who were asking about how do you make a door that opens both ways, like a saloon door or something. Nope, going to cheat. It's just going to slide straight up in the air. But let's right-click, and we'll say create a new blueprint class. We're just going to base this off of actor. And we will call this interactive door, like so. And let's open this up. Awesome. Now, here is how we implement the interface. This is going to be a receiving object, right? In terms of our communication, we have the sender, that's going to be the character. Now we need to worry about the receiver, and the receivers always have to implement the actual interface. We do that here inside of class settings. So we click on class settings, we go under the implemented interfaces section over here, click on add, you'll see iInteractable, click it, and there you go. Now, before this will work, before this will do anything, you must compile. You must compile. I have to drill that home for some folks. If you just jump over here to the event graph, remember, one of our functions was called interact, right? So you're gonna be like, all right, cool, man, let's just make an event out of interact. So you right click and you type interact, and you get call function, and you're thinking, oh, wait, that's not what I want, because that's not an event. And so you'll start getting confused and you'll start getting frustrated. If you compile and you try that again, you'll notice there's a new thing for adding the event. So when you're trying to set up an interface and you create your function and you right click and you don't have the event, please compile before you jump on the forums, and it'll spare you what I'm sure would happen. But it shouldn't happen. We have a really good community, but somebody might point it out to you. So we have our event here. So now what happens in response to this event? Now something else happened, and it was super subtle. Nobody noticed it, or you might have noticed it, and if you notice it, good for you. Take a look over here in our My Blueprint panel. Under interfaces, you'll see there's now a function called getInteractState. This magically appeared the moment we added our interface. So now that function is there and waiting for us. In fact, let's take a minute and go ahead and implement that. It'll just take a moment. We can double click it, and look, we have a function. The difference between this and the interface is that now we can start adding nodes and make things happen. So we have this thing called interact_state. It's just a Boolean. I'm totally going to cheat. I'm going to right click on this and promote this to a variable, which I will actually call interact_state. Aha. And there you go. This is just going to report this out into the world so that we can make use of it later. Okay, so now with that out of the way, let's go back over here to our event graph. Now, on interact, what happens? This event means that we just received a message from some sender. Somebody just called interact on us. And the only reason we had interact is because we implemented this interface. So that interface, again, was kind of like our wire. So now, let's cause something to happen. I don't know what. It doesn't really matter what. We're just going to make it happen anyway. So let's see, let me make sure that I'm following along with the things I want to talk about. We need, I guess first off, we need a door in here. So let's go over to our viewport and let's build something. I'll begin by adding components. Let's add a cube. And I'm gonna scale this and make it into a really gnarly door, right? So we'll scale it in X, and we'll scale it up in Y, maybe give it a little bit of thickness, right? Really, I'm just basically making a big plank that will block off the player. Now, on top of this, I am also going to add something just for functionality's sake. You don't always have to do this, but you should know about this kind of thing. It'll help you. If you hit the E key, remember what that does? That sends a sphere trace out into the world. We basically build this capsule, and anything that hits that capsule, we're interacting, right? Awesome. So imagine walking up to this door, and you hit your button, and that creates your capsule, and that capsule hits the door, and everybody's happy, and the door says, awesome, now it's time to open. So the door opens and slides way up into outer space. So it's open. Now how do you close it again? Because your capsule just goes forward and then it can't reach the door that's sitting way up there in the world. So what we're gonna do is we're gonna make another invisible object that will handle those kind of interactions when the door is slid completely out of the way. We'll do a box collision. Aha! And we will make this roughly the same size as the door. It doesn't have to be perfect. In fact, it doesn't even really have to be particularly close to that size. Wow, I scaled that up to crazy town. Let's bring that back down. Let's just do 1 by 1 by 1. Aha! And then I'll do some scaling by hand. Let's do just a little bit of thinning here. We'll make it reasonably tall. Again, does not have to match up with our door exactly. It looks like I got it pretty close to being exact anyway, and that's also fine. The important thing we're gonna do with this guy, this is the part that will throw a lot of people off, is we are going to adjust its collision so that the only thing that's actually going to hit it in terms of our game is just that trace. And how do we do that? Let's take a look back over inside our third-person character for just a minute. Remember our trace for interaction macro we built earlier? If we jump inside that, remember we had sphere trace by Chanel, or I'm sorry, by channel. And that is going to trace along what channel? It's tracing along the visibility channel. Kick something. Kick rear end. I almost said something else. So now if we go over to our collision settings for our box collider and we take our collision presets, let's just set this to custom. If we want to, we can tell this object to ignore all collisions except trace responses for visibility. Those will overlap, or those will block. That's it. So now this thing will basically ignore everything except that trace we set up for interaction. That is a very neat trick, and you should make sure to add that to your bucket O tricks and all that fun stuff. Okay, cool. So we've got that. We can now interact with our thing. We just now need to set up a way to get our door to move from one location to the next. There's a lot of different ways to do this. The way I'm about to do it is not even necessarily the quote-unquote best way. It's just a way that I use a whole lot, especially for demos and especially when prototyping something when I don't exactly know how it's going to move at first. So here's what we're going to do. Under variables, I want you to create a new variable called start location. We're going to make that a vector variable type, like so. Go ahead and compile. Next, select your actual door. In fact, let's take a moment and we'll rename this to door, D-O-R, I know how to spell. Let's grab the location of the door right now. You'll notice I did move it up into the air, so it has kind of a unique location. You can right click on this and copy it. Come over here to your vector variable for start location, right click and paste, and that'll paste all three of those values in. If you didn't know you could do that, and I'm often surprised by how many people didn't know you could do that, that's also another pretty handy little trick to have. Next, let's add another variable. We will call this end location. Aha! And we will compile as well. Now this one we're going to be a little bit on the fancy side for. We're going to take our end location and we're going to set it to something like 300, but that's just totally a guess. On top of that though, we will make this editable and we will show the 3D widget. Make sure both of those checkboxes are active and then you can compile. And when you drag this into the world, you'll get a little diamond object that you can move in order to update the location of that vector, which is pretty handy. Now right now this isn't going to do anything, but still, since it's here, since we've already added it in, I'm going to put it right in front of the stairs, so it's kind of door-like and kind of blocking off the stairs. It doesn't have to be perfect. This is all for testing purposes anyway. Now let's go back into our interactive door and jump over to the event graph. So what has happened? As far as our door is concerned, we have this event, which means somebody has called interact on us, and we want something we don't even know what it is, to happen. And what's that going to be? Well, let's make a timeline. Timelines are great for animating objects inside of blueprints. Let's make a brand new timeline, and I'm going to call it door timeline. We'll double click. Inside of this timeline, I will create a new float track. On this float track, I'm just going to hold down the shift key. Click once, click twice. Doesn't matter where, doesn't matter what you get out of it, because you're going to have to edit it anyway. Select that first keyframe that you just created with your shift click, set its time to 0, set its value also to 0, which is already done. Haha. Let's grab our second keyframe, so click on that, set your time to something, I don't know, anything you want. We'll do 0.75 seconds, so it's a fairly fast door. Let's set our value to 1. Now we're going to frame that up. Hit your little arrow buttons to frame that into view, and I'll zoom out a little bit so you can see the curve that's defined here. Let's grab both of those keyframes. I'm going to right click, and mostly just for vanity's sake, we'll make those auto curves. They get a little bit of curvature, so we accelerate and then decelerate as the door opens. Okay, wicked. That was fun. So we're done with the timeline now. Let's go back out to the event graph. Now, we're not just going to plug interact to play or play from start, because if we were to do that, then, spoiler alert, we would have a door that opened but never closed. So we're going to do a slightly different implementation that will allow us to also close the door. But let's talk about the motion of the door. It's fairly easy to set up. Now notice on our timeline we have new track 0. That's because I didn't name my curve. Let's jump in and fix that problem. If I take this curve, we can right click on it and rename it. Let's call this door interpolation. That's a long name for that, but it makes sense. It makes me happy. So now we have a door interpolation wire. We're going to drag a wire off this and make a lerp node, which is short for linear interpolation. Now it's going to automatically plug that into A. We're not going to leave it in A. We're going to hold down Control and plug that into the alpha. Actually, that's terrible. That's not what I wanted at all. Ignore me. We're going to do a new lerp. So just right click and type lerp. And we're going to do a lerp between vectors. That's what we really wanted. We'll plug that into alpha instead. Because what we're going to do is an interpolation between 2 different vectors, or 2 points in 3D space. And what are those points? You guessed it. Start location and end location. That's it. That's all we have to do. So as this plays forward, it's just going to output some blend in between those 2 locations. Next, we need to just feed this over to our door. So let's grab our door mesh, drag a wire off of this guy, and we will say set relative location, because those vector variables are in relative space. So as the timeline updates, we will set our relative location to some blend between the start and end point. That's pretty cool. That should work, unless I broke something. That only happens 5 to 52 times a day. So now we have our event interact. Where do we go from here? Well, earlier we set up this little interact state. This is a Boolean, so it's going to be true, false. So we're going to make an assumption here. When someone has interacted with the door, it will be open, and therefore the interact state will be set to true. When the door is closed, nobody's interacted with it, therefore we'll set the state to false. Knowing that, we can leverage this. Let's take our interact state, and we'll get a reference to it, and we're going to do a branch off of this, which you can always drag a wire out and type in branch, or if you're super cool, you can just hold down the B key and click, and that'll create those for you. So we'll connect that up. If interact state was true, then what do? That means somebody has opened the door. Well, we want to do 2 things. The first thing we want to do is take our interact state and set it back to false. We want to reset that. If interact state was false, then we want to set interact state to true. We're just flipping that value. By the way, if you are feeling particularly fancy, you can do that in one node, but you're still going to have to split it up in order to operate your timeline. Okay, so, and we're not going to dig into all that. That can just be one of those fun little challenges, and then you'll see why I did it this way. So now, we've got that, right? If it's false, we're going to set it to true. If it's true, we're going to set it to false. But think about this for a minute. If interact state was false, then we're going to set it to true, and then we need to open the door because the state was false. That means the door was closed. So we'll hit play. Then, if it turned out that interact state was true, that means the door was open, so now we need to close it, so we'll say reverse. That's it. Should be all we have to do. So let's compile. I'll hit save. In fact, let's go out to our level and hit Control S in case the very worst happens. Now, moment of truth. We're gonna walk up to this guy and hit E. Whoop, and the door opens. And I can't quite run into it because I think it's too low. But the nice thing is we have this little end location diamond. Let's just drag that higher up into the air and test again. And now it gets out of our way and everything just works. So it's a really good argument for using those editable variables. It's also nice because you can take that end location and over here in the details panel, you could potentially zero it out and then come over here and be like, well, what I really wanted was for the door to slide out of the way like so. So I want it to move side to side and not up and down. So whoop, and it slides. Now granted, that diamond denoted the center point of the door, so you'd have to kind of figure out where about the middle is. I'm gonna eyeball it real quick and try again. And you see the door kind of slides over. Now, here's the other part of this. Because we have that box collider. In fact, you know what? To make this really apparent what just happened there, I need to do a couple of things. First, let's take our box collider. I'm going to select that, and then under rendering, let's take hidden in game, and we'll turn that off. Next, here inside of our timeline, I'm also going to check use last keyframe, so we're not playing a whole bunch of other animation we don't need. We'll compile and hit save again. So now, when I hit play, you can still see that box sitting there. So I hit E, and it moves, but I have to hold the camera still because temporal anti-aliasing is a thing. You can still see that box sitting there. That box is sitting and waiting for us to interact once again. So if I hit E again, whoop, it reads it, and it closes the door back. So now I have an interacting door. But we could come over here to this static mesh, which does not have, it's not interactable. It's not something I ever need to interact with. And I could just hit E, and nothing happens. Which is kind of drives home the point of interface communication. If you have the interface implemented, something can happen. If you don't have the interface implemented, nothing happens, but it doesn't matter. You're still going to be playing your game. Now, we also implemented the F key, which is going to return our interact state value as per our little function. As a quick reminder, here's how that worked. Let's jump back into our interactive door for just a moment and take a look at get interact state. All it's doing is grabbing that Boolean, firing it out into the world. And then on our third person character, when we call that, we're just getting that interact state and printing it to the screen. So let's test it. We run up to our door and we hit the F key and we should get false because nobody has interacted with the door, and we do indeed get false. Let's hit E and open the door, hit it again, and now it's true. So you've seen how interfaces can be implemented as an event and as a function, albeit in a pretty basic way. Now, one more thing I wanted to throw out for anybody who wanted to do it. This is a super academic example, but it's also mega important for you to know about, and that is how to use interfaces as a way to handle level blueprint communication. So quick spoiler alert. You are not going to easily be able to communicate with the persistent level. Your basic, the level that exists as soon as you start building a map, communicating with that can be done, but it's not the easiest thing in the world. If you know you're going to want to use the level blueprint and you know that you're going to have a lot of crosstalk between that level blueprint and by other things, then you want to have a sub-level, and that sub-level will need to hold the level blueprint that you wanted to build. And if there are any blueprint objects that need to talk to that level script, make sure they're in that sub-level as well. All right? So just remember that I said that because this example is going to be a little bit on the academic side. So let's hit escape. Show this off. Let's go to Window. Let's go to the Levels editor. And I generally always dock this up behind the World Outliner. It makes me happy, so that's where I'm going to put it. And under the Levels menu, I'm going to create a new level, which I will call, I don't know, script sub-level. It's a boring name, but it tells what it does, which is great. Now next, super important, right-click on this guy and set its streaming method to always loaded. We're not going to worry about streaming this in and out, but it is important to note that if you try to communicate with a level that is not streamed in, that you will get problems and you won't get expected behavior. So if you're going to do what I'm suggesting here, which is have a layer or a level that is just for blueprint communication, then make sure that it's always streamed in. unless you had to stream it out for some reason, in which case just know to only talk to it when you have streamed it in. Okay, so now once we have that, here's the cool thing that you may not have already known. You can go under blueprints. You can go down to sublevels now, and you'll see edit script sublevel. So there's our sublevel blueprint. And here's the fun thing. You can now go into your class settings and check it out. There's an implemented interfaces section here. You can implement interfaces on sublevel blueprint. You can't do it in the persistent level, I'm really sorry, but you can do it here, which is a pretty good consolation prize. It's not the new Corvette, but it is a pretty good Mustang. So let's go here, let's implement iInteractable. And really that's pretty much all we have to do. We now have access, if we want to, I would have to break my door, or I have to break something to make this happen. So what I'll end up doing, let me break the get data function, what I have slaved to the F key. So I'm going to right click, and let's just, actually, as soon as I did that, you'll notice that over here in interfaces, we have get interact state. So we could just set this to something, right? Let's just make a variable here inside of our level. Interact state. Aha. Now again, guys, I'm gonna keep this super academic, guys and ladies. This will be mega academic. I'm just gonna hard code this to true, and we are just going to reach up from the character and get this piece of information. I wanna show you how that works. So let's take query data. I'm gonna disconnect it from all this stuff because we're gonna do something totally, well, mostly different. You can right click on any blueprint and you can say get streaming level. This only works with sublevels. It's not going to work with the persistent level. That's how this is. That's just what you have to deal with. Package name equals level name. So what did I name that level? I named it script sublevel. Type it out just like that. Say script sublevel and press enter. So it's just going to, what you're basically doing is saying get a reference to that sublevel by name. Now with that, we can just send it a message. We could say, get interact state. So we're just sending it a message that has a return value, which we're expecting to be true because we hard coded it to that. Or actually, you know what, guys? Let me do this. I want so desperately for there not to be confusion. I'm going to go back over to iInteractable and I'm going to add a new function. We're going to call it level comm. That's it. So like short for level communication. We will add an output, and we'll make that output a string. Okay? We'll call this the level string. Okay? Now I'm only doing this just to make this a little bit clearer because I feel like if I overuse the same functions over and over again, somebody might be like, wait a minute, how did he do that? And I don't want that to happen. So let's go back over to our script sublevel, and you'll notice there's now a level comm over here as well. We can re-implement this. So let's hard code this, right? You have successfully communicated with the sublevel. Ha-ha, that's a long message, but that's fine. So now we'll compile that. Let's go back over to the character. And now we get a reference to our level by name. And let's just send it that particular function, which again, we called level comm. So we'll drag a wire out and we'll call level comm. We don't have to worry about casting because we don't care if this guy has the interface or not. If it has the interface, it'll do something. If it doesn't have the interface, it'll do nothing and we don't care. Now let's just take this and let's print it to the screen with a print string. Done. Cool, let's compile, let's save, and you're getting a warning. It says return value is already a level streaming. You don't need a using this. So what it's telling me is that that functionality is already there. So we could just say level comm. Oh, I see what it's saying. So yeah, I'm not gonna hammer on that too hard. So let's just compile and move forward. I don't even think it should necessarily be telling me that right now. So let me come back over here to our subscript. Let's just test it. So I'm gonna hit play and hit F, and you have successfully communicated with the sublevel. So just straight up from an academic perspective, and it's possible it should be telling me that. I don't think it should be. It should be too worried about that. So return value from this is already level streaming. So it's saying we don't need to be using our iInteractable. I think we do, because we've got to send that through the interface, but we're, again, not going to over-iterate on that. The point is that it works. The point is we just did something that communicated directly with a sublevel, and that allowed us to use level script for those times we need to do that. So the point, when you need to communicate with level script, consider keeping all your level script in a sublevel specifically for that purpose, and you can always reach out and touch someone, to use a really, really old slogan. Okay, so with that, let's jump over and take a look at some questions. Let's see, some of these will be best served at the end, which is fine. Is it best practice to create health as a blueprint component? There's so many ways to implement health. Let's talk about that at the end. I'm looking for questions specifically about interfaces. Well, I guess it wasn't it? Is it best practice to create it as a blueprint component and use interfaces rather than direct communication for every actor that has health? It really depends, right? If you had a class, like a parent class, that was called something like living object, and then all of your things that had health inherited from that, then everybody immediately has health, and then you don't really need to have an interface. You could do it. You could add a component. I try to advise people against getting too heavy with components. It is a development path that we have not tested super heavily at Epic. You can make blueprint components, as you might have seen. I've even done some training videos over them. I think they are the bee's knees. They're super cool. But if you get too heavy with them, say for example, you have like 40 different things that your object can do, and so you make a component for each one, and now you have this one object with 40 different components. Now spawning that object in is significantly slower than if it didn't have all those components. So be cognizant of things like that, right? To me, a health property is something that would be common throughout all objects of a similar type, right? Anything that needs to have health is going to have it. So I would just have a parent class that had health and go from there. It's going to be much simpler than trying to add the same component to everybody. But because component-based programming is what it is, you could go either way. If I want to function to affect multiple enemies in a game, would it be better to create an interface function or to put them in an array and make a for loop and then loop each node? It depends on so many things. One of the ways you could do that is with an event dispatcher, which we'll talk about next. Your massive attack, like let's say what you're talking about is like an AoE attack, right? Like that's the first thing that comes to mind. I hit a button and this big ring wave of fire casts out from me and it looks amazeballs, and then everybody who's nearby gets hurt by it. Well, what could actually happen under the hood, and we'll talk about event dispatchers in a minute, so if you don't get this, that's fine, just sit on it. The moment your spell goes out and hits everybody, all that does is that passes a reference to everybody saying, hey, I'm about to do something, so here's a reference to me, and then everybody can start listening out for the effect. Or you could really go so many different directions with this. Neither one of the things you said is necessarily wrong. I guess if I had to do it either way, I'd probably do both. So what you said, just to do either or, you said would it be better to create an interface function or to put them in an array and make a for each loop node? The answer is both, probably. You are going to get an array of everybody you just hit with your AoE, and then you're going to call that interface function on all of them. And then only the enemies that need to be affected by it who got that interface implemented are going to be affected by it. Anything nearby, like a chair or a piece of shrapnel or something that was just sitting on the ground that doesn't need to be affected, won't have the interface, won't be affected, and your game will just continue on. So the answer is yes to your either or question. I love those. Maybe this is already answered, but is having many event dispatchers actually slowing the game down? It depends. It shouldn't be significantly slower, but I mean, I imagine if you went into a really high digit number in multiple factors of 10, that could be a thing. As always, your best option in those cases is to start profiling, right? And see how much CPU you're eating up by calculating all of this stuff. Okay, so with that, let's go back to our mighty PowerPoint presentation. And let's talk about our final topic for the day, and we are a little over where I wanted to be, so sorry for carrying on a little bit long. I'm gonna take just a second, rehydrate. And we're gonna talk about event dispatchers. So event dispatchers are kind of, they're different. They freak some people out, and they shouldn't. I find a lot of folks are not comfortable with event dispatchers because I think there might be a little bit of inadvertent mystery around them, so hopefully today will help get rid of that. So what are they? First off, event dispatchers are a way to establish a listening type relationship so that the receiver is listening for an event on the sender to take place, and then it can just respond however it likes. So previously, in both direct communication and in interfaces, we had a sender that just actually does something, right? It makes that interface call. It grabs a reference and says, hey, you, I'm going to do this thing to you. I'm going to send you some data. I'm going to pull some data from you. I'm going to call some functionality. The sender is doing something. Now what's going to happen is the sender is going to be like, hey, whatever, I'm doing something, and anybody who cares about it should respond. In a lot of ways, it's like Twitter. And this is probably the best analogy. If you're ever confused about how event dispatchers work, keep Twitter in mind. So the way it works is you will set up an event dispatcher on the sending object. And this is exactly like setting up your Twitter account for the first time, when you go to Twitter and you create your username, etc., and so forth. Then any number of receivers can then bind to your event dispatcher. So this is just like people following your Twitter feed. Whenever you send out a tweet, these are the people who will be listening. They're the ones who will actually receive your message. But keep in mind, just kind of from the Unreal side of things, the receiver will need a reference to the sender. That's why event dispatchers are different. Up to now, the sender gets the reference, the sender makes the call. Now what's going to happen is the sender isn't even going to bother with a reference, it's just going to make the call. The receivers will get a reference to the sender and say, hey, let me know when he makes a call to this one thing, or to continue with our analogy, let me know when he makes a tweet. So next thing that happens is the sender will call the event dispatcher. This is exactly like making a tweet, which is just sent out into the ether. By the way, this is the closest thing we have to that widespread broadcast approach to communication that a lot of people ask for. So he'll just send that out to absolutely anybody who might be listening. And it could be that nobody is following the sender. It could be that nobody has bound or has a bind to that sender, in which case nothing happens. So this is a lot like when Chance, for example, Chance makes a tweet. Nobody loves it, nobody responds, and Chance comes to me crying. That kind of thing happens from time to time, right? It means that tweet happened and nothing happened in response. The followers didn't care, or maybe at that point there were no followers. It's okay, Chance. However, if there were followers, and maybe this time Chance actually says something interesting, then they'll be like, oh, Chance just said something cool. Let's go tweet about it. Let's go get on Facebook, or let's go to the web page he was talking about, and then Chance is happy. So the moral of the story is, be nice when Chance tweets. Say something good to him. He needs that. So anyway, the last thing is any of the receivers who had an event bound to the event dispatcher can then react accordingly, which is kind of what we were going through. Now, well, I guess let's continue with our slide deck before we move on. Now, when do you use event dispatchers? How do you know when an event dispatcher is the right call? When you have an event on the sender that you know needs to be sent out to a lot of different things, and each one of those things could be doing their own thing in response, right? Like maybe you've got a boss character in your level, like this great big toad-looking boss character. And the moment he dies, you want the walls behind him to crumble to the ground. You want the torches that were surrounding him to all go out. And you want music to start playing. And you want the character, which looks a lot like Chance, to do a victory dance, right? Maybe you want all of that. So in that case, what you'd have is something that was sent out the moment the boss died, and all these level elements, like the torches and the walls and whatnot, they would be the receivers, and they would just respond however they were supposed to respond. So whenever you start off knowing who the sending object or what the sending object is going to be, but you don't know and you don't care how many receivers there are. There could be none, there could be many. It doesn't matter. You just know that we're going to send something out and a bunch of folks are going to have to respond to it. Then it's probably time to use event dispatchers. You need to make sure that the receivers, all the receiving objects, can somehow get a reference or in some way know about the sending object. So that's, again, that's how they tie into that Twitter feed, for example. And then the receivers are also going to have to know when to start listening for specific events and possibly when to stop listening. For example, you could, if you wanted to, just as a challenge, think about this. Once we've talked about event dispatchers, how could you implement an event dispatcher as a form of interaction? You could have it so that when you walk up to a door, for example, the door starts listening out for when you interact with it. And so you hit your interact button, the door says, hey, you came into location, and boom, that opened up the door. But when you walk away, we need to know to stop listening, so that the next time you hit the E key from across the room, the door doesn't close from super far away. It's knowing when to stop listening, potentially as well. There may be some event dispatchers which will run the entire course of the game. The one we're going to set up is going to run indefinitely, but just know that as you can bind things, you can also unbind them so you stop that relationship. Next, event dispatchers in action. These are a little more like classic functions or even variables in Blueprint. You're going to create event dispatchers in the My Blueprint panel of the sending blueprint, not in the receiver. The receiver doesn't care. If you have to pass along any data, like current health, which is what we're going to be doing, then that will become an input. And we'll discuss signatures for your event dispatchers here in just a moment. Don't even worry about what that word is. We'll come back around to it. Now, an event dispatcher cannot have an output. That would defeat the purpose. The purpose of an event dispatcher is that you're just sending out some data and you do not care what happens with it. Nothing might happen to it. It doesn't matter. You're just sending it out. And because of that, you don't care about return values. Nothing might happen, and that shouldn't change anything. Now, at some point in your event graph, your sender is going to have to call this event dispatcher, and that's a specific word. You're going to be using it. Call the name of this event dispatcher. And to do that, you can just drag a reference from the event dispatcher into the graph, and you'll choose call. We'll talk about that, and you'll see that in action here in a few minutes. Over in the receiver class, you must first have a reference to the sender, and it's your responsibility to get that. Again, just as a reminder, this is why event dispatchers are different than the other two types of communication. This time, it's the receiving class that gets the reference and not the sending class that gets the reference. So once you've got that, reference and you've confirmed that it is the class you care about, probably by way of casting, then you can bind an event to the event dispatcher by name. You can create a custom event that will connect to the event pin, and then whatever you tie into that custom event will be what executes. Just keep it, and again, if that doesn't make sense, don't worry. You're about to see it in just a couple of minutes, and you'll be like, oh, now I know what he was talking about. Just know that you may need to stop listening at some point. This just means unbinding the event, which we will explore, but we're not going to practically do, because what we're going to do is create a really quick HUD, and we'll use event dispatchers to transmit data to a HUD, which is a super efficient way to handle that, as a quick note. Now, if no objects have made a bind to an event dispatcher, then nothing happens. That's simply it. Nothing will happen in response, and this is perfectly safe. That's totally fine. This means that when you're setting up event dispatchers for the first time, you can just set up your first one for your sender, and then know that later on down the road, you can tie things into it. And that may come tomorrow, that may come late in your gameplay, or in your game design, right? You know that it's there, and you could hook things to it if you want to. Next, event dispatchers on the sender and kind of what they look like. So from the sender's perspective, you only need to set up the event dispatcher and then call it at some point in the event graph. That's it. That's all there is to it. This is generally going to be in response to something important that you care about, because it's a lot like calling a function. Notice that the call itself does not require a reference. I keep driving that home. The sender doesn't have a reference, and that's how this form of communication works. Now, on the receiver, it's a little bit different. Any object wanting to become an event dispatch receiver must have, or obtain somehow, a reference to the sending object and must bind its own custom event to that dispatcher. So this custom event must have the same signature as the event dispatcher, and again, we'll talk about that here in just a second. Once the bind is complete, then the system just sits and waits. So again, that's just like tying into your Twitter feed. That's like following somebody on Twitter. Because right after you got your mobile device and you're like, oh yeah, Chance, he's awesome. I'm going to follow him on Twitter. Then what do? You wait. And I imagine this is what Chance expects. He imagines everybody just waiting patiently for him to text and just staring at their phones the whole time. But in a way, that's what you do. You just sit there and wait for him to make a tweet. And then as soon as he does, haha, you see it and you can respond. And that's exactly how event dispatchers work. First, you make that bind, then you're following the event dispatcher, and then you wait. And the moment that event dispatcher is called, then this stuff connected to the event, which you'll see here in my little picture, all of this stuff will fire. And that's what that little red line is for. If you haven't been playing with event dispatchers, you might have been like, hey, what's the little event wire for? And now you know. I'm sure none of you actually talk that way. So event dispatcher signatures. A signature is just the combination of different inputs that an event dispatcher can have. These are specific to each individual dispatcher. They can be shared if you have different dispatchers that need to be sending the same data. You can share their signatures. There's just a little drop down where you can share a signature when you are creating your dispatcher. I tend not to use it that much, but it is there. And then signatures are really the way that you make dispatchers intelligent. You can test the input data and do different things on what you find, right? So we are going to be using an event dispatcher to send an amount of health up to a UI. Your UI could be smart, and it could say like, hey, did the amount of health just drop down below a certain level? Because if it did, then let's change the color of the health bar from green to red, right? In response, to let you know you're low on health. Now, Unreal does most of the heavy lifting for managing signatures these days. If you're using a really old version of the engine, and I don't know what really old means. I think it means 4.5 and earlier, but I could be completely off on that. I just know a long time ago, you had to handle a lot of this signature setup yourself, and now you don't really have to worry about it so much. In fact, I'm only mentioning it here just so that you're aware that it exists. But for the most part, you don't have to stress this. Next, event dispatcher options. When you drag an event dispatcher into the event graph, or when you right-click and try to access them from inside the receiver, you're gonna see a lot of options, and you should know what they all mean. You'll see call, bind, unbind all, event, and assign. Call is just gonna broadcast the event dispatcher to any receivers. Basically, you're only gonna be using call from the sending object. The receivers will never really need to worry about call, generally speaking. You might come up with an exception. Bind. This will create a bind node, which if we jump back, this is a bind node, this guy right here. So that is how you're going to attach some event to your event dispatcher. All it creates is that bind node and nothing else. Unbind is going to create, you guessed it, an unbind node. This is just like snipping that red wire at runtime. So it's just like saying, hey, I don't want you to listen out for this event dispatcher anymore. You can also create an unbind all. This will unbind all events from that event dispatcher across all objects in the game. So for example, if you had an event dispatcher that was tied to a character, so that, let's go back to our boss fight. You got your great big toad character and he's fighting the hero, and every time he casts this one certain spell, it causes all the torches in the room to flare up and the music gets dramatic for a moment and the camera zooms in and all this stuff happens in response. But after he dies, none of these objects in the level need to be listening out for that anymore. So once the character is dead and we don't care about him anymore, you might call an unbind all to just sever all those ties so that you're not listening out anymore. Next, we have event. This is kind of a shortcut. This will create a custom event that has a matching signature. So if you don't want to do it by hand, you could just use event and that'll do it for you. And then finally you have assign. This is another shortcut. This will create a bind node and an event already wired together. So it's just a way for you to get the job done a little more quickly. If you know that you still need to create the bind node and you need to create the event node and you're going to need to wire them up, it's significantly faster to just call assign instead, and that'll do all the heavy lifting for you. Okay, so let's give a demo. Let's talk about event dispatchers. So I'm going to jump back over to the level and let's make a UI. And I chose a UI for a very particular reason. If we go over, actually, I'll get to that. Let's just make we'll right click, I'll create a widget blueprint, which if you were looking down, sipping your soda or whatever you were doing, here's how I did that. We right click, go under user interface and make a widget blueprint. And we'll call this health UI. Like so. I think I even spelled it right. That's awesome. We'll double click this and we're going to build a really, really basic UI. So don't look for anything super fancy here. We're going to go under panel and we'll grab a horizontal box and I'll drag that into the upper left-hand corner, make it nice and big. And I mean, that's pretty good. I'll bring it down just a little bit. And then inside of this, we will add some text. And I'm just going to set the text. We'll type in health : space. Press enter. After this, we will add a progress bar and just drag and drop that in. And now on the progress bar, we'll click the fill button, and that'll just fill that in the rest of the way. So now, of course, we have this % value that just controls all of this, which is great. Fantastic. All right, now one thing I do want to verify, this will help us later, take your progress bar and make sure that is variable is checked. It should be by default, but you should always double check that, and we will rename this. We're going to call it health bar, which sounds like a place to get a smoothie. All right, so now we got our health bar. That's awesome. We're going to compile and save, and now let's take a quick break and jump over to our character blueprint, and let's get this so that it shows up during our gameplay. So we'll zoom in. Now, let's see here. We're going to say on begin play. What are we going to do? We are going to create a widget. And it's going to say what class? Well, that'll be the health UI. Now, you do not have to assign owning player. I think it's good practice to always assign owning player when you're building this kind of UI, so I'm going to do it. Owning player is expecting a player controller. So what I'm going to do is say, oh, here's the thing. We know we are inside a third-person character class. We also know that the third-person character class is also a character class, which is in turn a pawn. So let's do this. Let's just type in controller. And we have get controller. So this is literally making a call to whatever controller is driving our current pawn, which is us, because this has a reference to self. So it's, hey, what controller is driving us right now? Because it's probably a player controller. But we need to confirm that it is, in fact, a player controller. So I'm going to right-click and just type player controller, and you'll notice you get cast to player controller. Now, you can also, if you're feeling particularly fancy, if you know this is going to be a player controller at all times, you can right-click and make this a pure cast. Tell me that isn't fancy. And now that doesn't even require its own execution wire. That just runs right through. That is only useful if you can pretty much guarantee at all times that this will be a player controller, which is great for a playable character, so that'll work out fine. So we've now created our UI. Now, as just a general thing, once I've created a UI, I will tend to put it inside a variable. I'll call it character HUD. And then once we've done that, we will add it to the viewport. You'll see a couple of options as you type add to. You'll see player screen and player viewport. Well, this lecture is not about UMG, but in case you're wondering the difference, player screen is for split screen. We're just going to add it to the viewport and keep this simple. Okay, done. Awesome. Compile, save. And I'm not going to worry about the little warning. We know that's all tied into the level script. And since it's going to drive me crazy and I have a little bit of the OCDs, we're just going to delete all that out. You saw that that works. You saw that you can get a streaming level by name. It only works on sub-levels, and you can use that to your heart's content. Merry Christmas. Okay, so now we can hit play. And there's our health bar. It's marvelous. It's actually way too long, and it's kind of hideous looking, but it will get the job done. So now, here's the thing. In UIs, particularly in UMG, it is very easy to bind data to a given property. For example, I could take this %, and I could click on bind. I could create a binding. I'm not actually going to do it, but this creates a little function that in that function I could say get the owner, make sure it's a playable character, get its health, and then drive that using the bind function. That's great. It'll work perfectly. What it won't do is be performant, because binding, when I bind data, that updates on every single tick, and you should reserve that and only use it during those times when you know for a fact your UI has to update on every frame, and more often than not, it doesn't have to. For a health bar, it only needs to update when you affect the character's health. That's completely event-based. I've heard exceptions from people. They'll be like, well, what if I'm doing a flight sim and I have like an altimeter and I need constant readout of you know, what is my current ground altitude, etc. and so forth. You could bind that if you want to, but you'll probably discover that you don't have to do that on every single frame. You could get away with doing it maybe 10 times a second, or maybe a little more, maybe a little less, in which case you'd use a timer, and then it all becomes event-based again. My point is not that you should never use binds, it's that you should be really careful about when to use them. And we don't need binds in order to drive something as simple as a health bar. So what we're going to do is jump back over to our third-person character. And earlier, we were doing some stuff with our character's health. It was down here on take any damage. We were updating their health like so. And then we also had a healing volume that we called earlier. And that healing volume, I'm going to make a quick change to. I didn't plan this, but it's something you should know about anyway. So we've got our little healing volume. Do you remember what he was doing? He was actually grabbing the health value and he was setting it. I don't like this as a general practice. I don't like anybody else being responsible for setting a value of an object. You can do it. There's technically nothing wrong with it. Philosophically speaking, I don't care for it. Here's why. If I ever set something the wrong way, I don't want to have to dig through and be like, wait a minute, how was that set? What I would rather do is this. I'd rather go inside the third person character and do something like create a function. And we'll call this function heal all. And then all this function is going to do is take our health and set it up to 100. Now that is on the character. That is not on the healing volume. What that means is now the healing volume isn't going to do any of this stuff. In fact, it doesn't need to print string anymore either. All it's going to do is make a call to heal all. Now it calls that function. That's super useful because if I ever care about how much health the character has, maybe heal all should change that value, I only have to go to the character to set that. It also means that other objects that may need to heal the character can make a reference to that same function. Okay, so now with that, let's go back over to our character. Let's go back over to the event graph. So we have, on take any damage, we're going to update our health and then we were printing out to the screen. Let's stop printing. Instead, what we're going to do is use an event dispatcher. Here's how I make it. We will click on plus event dispatcher, like so, and we will call this update UI. Now, I need to send this some data, something that our UI can actually parse. So with the update UI event dispatcher selected, I'll click on the new button. And underneath this, let's call this health. Aha, and we'll set the data type over to float. Fantastic. Now, you'll notice there's also copy signature from. This is where you can copy off any signatures. So if you had another event dispatcher that had the same collection of outputs and you don't want to have to add them one at a time, click new, change, click new, change. You can just copy that from an already existing one. So you can just set it up once and it'll save you some time later on down the road. For us, it doesn't really matter. So we've built our event dispatcher. Now I can drag this event dispatcher into my graph and there's a little menu. Call, bind, unbind, blah, 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 all that stuff. You can read it yourself. We are in the sender, and the sender only has to call. It's just like making a tweet. So we'll connect that up, and we will transmit whatever our current health value is. Now, remember our function that we created earlier for heal all? So when this is called, it's going to set health back up to 100. Let's also make that call the event dispatcher. We're almost done, but not quite. Earlier, we added our UI to our character so we can see it when we play the game. But our UI has a default value for its percent, which is because I was playing with the thing, it's like 0.32 something or other. So what we'll do is as soon as we have added this guy to the viewport, let's also call our event dispatcher. And you can do this the other way too. You just drag a wire and say call update UI, and there it is. And we need to send this our current amount of health, so let's just drag our health straight out like so. And by using the variable, that means if we ever change our default amount of health, it'll send whatever comes in, which is great. So now let's compile, let's hit play, and oh, nothing happened yet, but that's because we haven't implemented our event dispatcher on our UI. Of course, that's the other side of this. If you never make the bind, nothing is listening, so nothing actually happens, and that's not useful to anybody. So let's go back over to our UMG. Let's go over to the graph now, and let's do some fancy things. First off, we have event construct. This is just like begin play for UI. So on event construct, we will get owner, and you see there's a bunch of stuff here. We have get owning player, we have get owning player pawn, and so forth. Let's go all the way to get owning player pawn. We're not worried about multiplayer, so I don't really care about whether it's local player. We'll just say get player pawn. Once we have that, we need to make sure that it is in fact the third person character. Why? Because the third person character is where we built our event dispatcher. So to do that, to verify we're talking to the right thing, that's right, we cast. So we drag a wire out and we cast this to the third person character like so. And now that we have access to that, now we can make a bind to that event dispatcher. So we can say bind to update UI, and there it is, bind event to update UI. So I can create that, and that creates our little bind node, but this is not complete. Now we need to drag a wire off event, and you can, if you want to, just click add custom event, and notice it automatically creates one with your signature. I was so happy when they added that. And let's call this something meaningful on this end. So this will be update health bar, like so. So now we have an event that will fire whenever that event dispatcher is called over on the character. Now real quick, because I mentioned it and I want you to know about it, you can also, once you have access to your class where the event dispatcher lives, you could say assign update UI, and there it is, and watch what assign does. Assign creates your bind node, creates your event node, goes ahead and connects them, and then it's just waiting for you to give it a name. So we'll call this update health bar. So it's a little bit faster, and I recommend you use that workflow just to save you a few mouse clicks. Cool, so now that's all connected up. So now where do we go from here? Well, earlier we had our health bar, and over in the designer we made sure that is variable was checked on the health bar. So now we see it listed in our variables, and we can drag a reference to it. And we can say get percent. Actually, we don't need to get percent, we need to set percent. Thank you very much. Thank you. Now, here's the thing. Percent, as you might recall, is a 0 to 1 value, not 0 to 100. So we need to convert something that goes from 0 to 100 down to 0 to 1. That's super easy. We just need to divide it by 100. So we'll drag a wire out, hit slash. We'll do float divided by float, divide that by 100, press enter, take this result, plug this into percent, and we should, generally speaking, be good to go. Now, let's do something else. Just because it's fun and because we can. Let's drag a wire out from this guy and let's say color. We have set fill color and opacity. Let's set this. And let's take our incoming health value and let's say if this is less than some other number, and let's make that other number like 0.2, so we're down to like 20%. And then we'll do a branch, we'll hold down B. Please tell me you're about to tweet that, Chance.
Not that one.
Okay. I'm getting photobombed right now, or that's not how that works, but it's something. Okay, so what are we doing? We're taking the incoming health, we're dividing it down to our percent, and we're saying if that's less than 0.2 or 20%, then we want to set the fill color and opacity. Let's set this to red so that we know that we're about to die and we can be truly afraid. And so forth. So I'm apparently way too picky about the color. So let's compile, let's save this. Hopefully it all works. Hopefully I didn't break anything, but you never know until you try. So let's hit play, and our health bar is all the way up to max, which is great, because remember, it had that default value somewhere between 0 and 1. Let's go stand in our hurt volume. Oh, and our health bar is getting low. Let's leave that. Let's go get healed. Ha-ha! It fills up. Now let's test that color thing. Down, down. We're hurting more. This is taking forever. Okay. And it turns red. We're almost dead. But then when we heal back up, nothing is turning it back to blue, right? So we need to come back in here. Let's go back over to our health UI. This was a branch. So if this turns out to be false, then we need to set this to another color. Now, truth is, I have no idea what that default color was, so I'm going to cheat. We'll go back out to the designer. We'll grab this color. Let's just get its hex value, which I should probably know that hex value off the top of my head at this point, but I don't. There's a lot of f's in it. And let's just click, paste that in, hit enter, ignore the candy wrapper, and then we will compile. And what's it saying? Well, it's saying that we don't have a target. Well, of course we should have a target. Also, wires that are this long drive me crazy, so let's grab that health bar variable, we'll hit Control-C, we will paste it over here, and let's just have a closer version.
We plug in over on this side. Haha. Now let's compile and everybody should be happy. And we'll hit play. And actually, you know what? Because actually, that won't work really well, will it? I wanted to make it so that this wouldn't take as long, but I guess I just have to change more things than I want to. So we'll just wait. And it's red. Oh, I didn't die though. And then, boom, we're healed up. Now, we're pretty much done. That's all the blueprint communication stuff I wanted to show. I'm going to do one more thing. This is just for the giggles. This is for shiggles, and if you know what that is, then good for you. When we get health that is all the way down to 0, because you notice we're doing all this stuff where we're checking health. Let's do this. So boom, on any damage. Well, we only care about this from the perspective of damage, and I'm not going to go super overboard on this, but if health ever drops lower than or is equal to 0, then let's do something kind of funny. Let's do something. Let's say we take our mesh. Actually, let's do something else too. Let's grab our mesh and let's grab our character movement component. And let's disable this. We're going to disable movement, so our character can't move when he dies. And then we're going to take our mesh and we're going to say, let's change its collision. Set collision enabled. Haha! We're going to enable collision on our mesh. It'll be great, trust me. And we're going to set this to for query and physics. Next, let's just drag this out and type simulate. So set all bodies simulate physics. Haha! Let's set that to true. We'll turn that on, and then let's drag one more wire out from this, and we'll say blend weight. There you go. Set physics blend weight. Set all bodies physics blend weight. That's what I wanted. Let's take that guy and connect that. And we'll set that to 1. So we're blending all the way over to full physics simulation. So real quick, as a review, we have a branch. If health is equal to or less than 0, we're going to take character movement and disable it. We're going to grab our mesh and enable collision. We're going to take all our physics bodies and tell them to start simulating, and then we're going to tell them to blend all the way over to pure physics simulation, so we're not paying attention to any more animation from the animation blueprint. Now, we can come over here and be like, turn and face the camera because it's funnier. And then health bar gets lower and gets lower. Oh my god, we're in danger, and it's red, and bleh. And we just, that's me every Monday morning right there. And then only because I think it's funny and for no other reason, we can take our damage per second, we can set that up to 100%, and then we could go over here to basic, we could drop a cylinder in here. This is just bonus, right? This is for impressing your friends, or your boyfriend or your girlfriend, to show them all the cool things you've done in Unreal lately. So we'll put a cylinder right in the middle of this guy, right about head to chest level, and then we'll hit play, and just run. Blam! I don't know why that's so satisfying, but it kind of is. And if you needed to see it from the side, which I do, there you go. So just something fun to play with. So that's it, right? So now we've talked about all different forms of blueprint communication. Are there any questions specifically about event dispatchers? Let me take a look over at our list of questions. For an interactive system, would you recommend an interface system like you showed? I'm currently using an event dispatcher bound to an interactable parent object, which validates if interactable. That is completely valid. It's really up to you. If you end up in a situation where, I mean, there's even a third way to do it, which you may not have considered, right? You can have a parent class which defines whether something is interactable, right? You can have a parent class called interactable object, and then that can have what happens when it receives an interact custom event, and then everything that can be interactable can just inherit from that and be child classes of that. That is just as valid. These are philosophical questions, and I'm not going to tell you that the way you're doing it is right or wrong. Keep doing what you're doing, and you will find one that works best for you. I feel like you should probably try all of the different forms of communication and see which one you're comfortable with, see which one makes the most sense. If you have multiple developers, make sure they're all on the same page. We'll talk about that in just a second. But I wouldn't necessarily recommend it, but I wouldn't not recommend it. That's the nature of a scripting language, which is all Blueprint is. There's a million ways to do everything. You have chosen another one of the million than the one that I showed you. Next, any tricks to manage all of those event blueprint wires and keep it pretty? I think somebody asked this earlier in the forums, and I told them what to do, but I guess I should demonstrate it as well. So over in, I guess what, the UI, we did this bind. Now you have to have this event wire. This is just how it goes, right? Now, if you end up in a situation where you had to have this sitting over here and you didn't like having the wire, like sometimes these wires get really long, in that case, what I would probably do then is this. I would say, snip this, create a new event, so drag a wire out and make a new custom event called something like update UI called. And then all this guy is going to do is he is going to call update health bar. And then you'll just take that health and plug it in there. So you're doing the exact same thing. You're just keeping this wire nice and tight, and now there's a wireless connection from this node out to this node. So that will keep it a little tidier, but you can't get rid of this event wire. I mean, you can do like a reroute node if you wanted to reshape it, but that's it. That's all you have. Okay, does destroy actor handle the unbind call? No, it does not. You're just now, you have something that you don't have a reference to and the listening is still there. So make sure that on death you unbind. And there's already an event dispatcher that exists for all actors called on destroyed. So there it is. I just typed out on destroyed and there it is. Assign on destroyed. So then you can stop listening. You can unbind everything. Is it possible to make the image blurry when health is low? The answer to your question is yes, but there's no easy way to do it because you don't have post-processing on UI at this point in Unreal Engine 4's life cycle. What you'd have to do is swap out for a series of textures that were blurry in and of themselves, which has got its own setup and is super involved and goes way off track of Blueprint communication and starts talking about UMG. But that's enough to kind of get your noodle baking. I guess real quick before I start going into all of the other generic questions, let me jump back over to our slide deck for one more second. I just want to run through a quick conclusion, some things I want you to think about, some last minute notes to jot down. As you've seen, there are lots of ways to get blueprints to communicate. Well, I mean, and by lots I mean 3, but there's a lot of different ways that you can implement those 3 different types. In many cases, more than one approach will apply, which I was just talking about just a moment ago. Just because there are other ways to do it doesn't necessarily mean that you're wrong. And it doesn't necessarily mean that you're right. You need to consider all the angles we've discussed here, and it should become clearer which one you should use, but also make sure you get together with your team and make sure you're using the communication method that works best for all the folks that you're working with. Maybe you do have a situation like interaction where a dispatcher will work just as well as an interface. Make sure everybody's on the same page about that so you don't have some devs doing it in an interface and some folks doing it using an event dispatcher. On that note, unify and standardize. Please do. This has nothing to do with blueprint communication. It has everything to do with using blueprints in general, particularly if you're on a team. Please think about this, right? Agree on what types of approaches you're going to be using under certain circumstances. If everyone is handling communication differently, it's really hard to work together. And that's true for things beyond communication. Make sure that you have a set of standards that everybody's using for your blueprints that you build. Ideally, your team will make a set of blueprint coding standards, a series of rules, right? Here's what you should be naming variables. Or here's our naming convention. Here's the way you should be ordering your nodes. Here is how you should be naming your custom events and how many custom events you have. Here's the maximum number of components you should have. Here's the maximum number of nodes you should have. There's actually more than one studio that I've talked to in my travels. They have written their own plugin for the editor so that if you add a node to your blueprint over, I think one of them, it was like, if you add more than 100 nodes, a modal window pops up and it says, go contact a programmer right now because you might be doing it wrong. So keep these kind of standards in mind. If you have a single blueprint with, let's just pick a random number, with 500 nodes, you're probably adding too much functionality into that blueprint. It's the same in code. When you're building a code class, you want to keep the amount of functionality in that class as minimal and as compact as you can. Think about these kind of things. Build these coding standards, use them immediately, and enforce them all the time. Now, every team is different. So because of that, Epic doesn't have a single coding standard that we think everybody should use when it comes to Blueprint. You're going to have to work with your team and come up with the one that works best for you and then implement it from there. Now, at some point in the future, it's possible that we may have a sample coding standard that you could reach from. At the time of this video, we don't have that kind of thing. But just keep that in mind, and I'll get off my pulpit and we'll move on. So now, are there any remaining questions over anything? Let me scan back over and see if there's any I missed. How to send variables from level blueprint to anim blueprint? Well, it's easy if the level blueprint can get a reference to the character or whatever it is that's being animated, because once you have the character, you can get that character's skeletal mesh component. The skeletal mesh will give you access to the animation blueprint, and then you can send data in there. Me, personally, I would never do that. I wouldn't have the level blueprint necessarily ever need access to that kind of thing. I would have some overarching or over-existing class handle it. It could be the game mode, could be the game state, could be the game instance, could be a custom class that I'm adding on my own. But because communication with the level blueprint, notice I'm not saying sub-level, specifically with the persistent level, because that's a little bit dicey, I try not to work that way. And you've seen how you could do some things with the sub-level that might be helpful. Let's see, next. We talked a little bit about the inherit classes question. Can I transfer the knowledge I will gain to C++? Can I just take blueprint nodes for casting and look them up in the framework and use the same functions for C++? Generally speaking, the answer is yes. It's a little different for interfaces. Interfaces are implemented differently in code than they are in script. That's just the nature of the beast. And I'm not going to be the guy who can tell you how to implement them in C++. I'll be perfectly frank, I'm not a big fan of the way they work. They're good. If you're a programmer, use them, but I don't like them. Next, I think, why is there a pain volume? We talked about that. How to reference a component of another blueprint. The target is the component, or does it always need to be the same type of actor? Well, you have some options here. There are some special nodes that will give you access to a particular component, like out hit, like a hit result can tell you what component you hit, and that can be useful. Overlaps, some types of overlaps, like component overlaps, can give you access to that component, and you can go from there. Beyond that, once you have a reference to the actor, you can then drill into any component that that guy has. So you can drag a wire out from that actor, and you can now access any of the functionality that exists on his components as well. So you just say, like, maybe he's got a character movement component. You could get a reference to the character and say, get character movement component, boom, and now you have access to that. But if you're looking to get that as an initial reference, there's only a few things that can do it, like some hits, some overlaps, and maybe a few other things past that. How would damage increment work with protection like armor? Well, I know everybody loves to hear this answer, but it's up to you. It's how you would like to implement that. What I would do is I'd actually have two sort of health bars where you'd have your health and you'd have your armor, and the amount of damage that your health takes is scaled by what's here in the armor. That's one way to do it. Like that way, in that way, if somebody like hits your heavily armored character with an axe, he still takes a little bit of damage, but the armor takes a big chunk of it. Or there's the other way, where you can think of armor like a shield, and that no damage penetrates to the character as long as the shield is up. So you're hitting him with the axe, and this just goes down, and when this hits 0, then you're affecting this. It's really up to you, and at that point, it's just multiplying some numbers together. But that's really how you decide for your game to work, and that's a little too specific for us to drill into in this discussion. Hopefully that's enough for you to kind of start fishing, though. Is it best practice to create health as a blueprint component and use interfaces rather than direct communication for every actor that helps? I think we kind of discussed that earlier on. I would probably have a base class that owned health, and I would either use, I could use it either way. I could do direct communication or I could use interfaces. To me, it hardly matters. It's just whatever feels right to you and the rest of your team. If I want, we talked about this, if I want a function to affect multiple enemies in a game, I would generally just do an AoE effect, and I would get that array of all the things, and I would run a for loop on them. Alternatively, you could have that AoE basically send out an event and a reference to itself so that these guys could start tying into an event dispatcher, though that seems a little heavy-handed to me. I don't think I would do that. I would probably just stick to create an array from everybody you hit, do a loop through that, and then maybe just use an interface to affect their health or something. All right, next. Question, is there a way to actually check if an actor is visible on screen? I mean, inside the viewport. That's outside the scope of what we're talking about. I'd like to keep these kind of narrowed down. That is a great question. Just throw up on the forums, though. For an Interax, what's the next one? Is having many event dispatchers slowing down the game? We talked about that. It shouldn't be bogging it down heavily, but again, testing is the best way to go. And generally as a rule, I would advise you never to overuse anything in Blueprint. Don't put too many nodes, and by that I could mean hundreds of nodes. Just be cognizant of that. Don't overdo it. Don't put too much functionality into a single blueprint. Don't add too many components to a blueprint. Don't have a huge complicated hierarchy of parent and child classes. You might be overdoing it there as well. Try to keep your blueprints simple. As soon as you start having to get into the much more hardcore relationships, it's possible you should be learning a little bit of C++ or maybe grabbing a programming friend. All right. Somebody said they're using Event Dispatcher to do interactable. That's fine. It's whatever works for you. I could just as easily set that door up to open and close based on an Event Dispatcher so that when I get close to it, we engage the Event Dispatcher and start listening. When I walk away from it, we stop listening. And then all that would happen when I hit the button is we'd make a call to interact. And that would work. That's perfectly valid. Does Destroy Actor handle the unbind all? I think I answered this one, and my answer is no. I'm 99% sure of that. There's a 1% margin of error in there. Might be a good question to throw on the forums. Is it possible to make an image blurry? Talk about that. Just do that with textures because there's no post-processing. Can you tell a bit more on performance on binding variables in UMG? I'm only binding to variables, not functions, but it is a lot of variables. You should be fine. Binding is not that expensive. Sure, there's a cost to it, but there's a cost for everything your character is doing. You can have many, many, many binds. Notice I'm not actually sticking a number in there. And you should be just fine. Just keep in mind, only have them open when you need them, disconnect them when you don't. Either way, it's still one of the cheapest ways to send data up to something like a UI. So I wouldn't be that scared. Let me put it to you another way. If you have so many binds that you're scared about it, your UI probably has too much stuff on it. And by that, I mean it is just a solid window of nothing but UI bits and you can't make anything out of it. Anything short of that, you're probably just fine. Outside of that, though, you should run profiles, right? You should run your CPU profiler on your UI and see where it starts to get heavy. So that's all of our questions. So I wanted to thank everybody for watching. We went a whole lot longer than I thought we would, but that's perfectly fine. Please make sure that if you have any further questions, please throw them into the forums. I'll be keeping an eye on our announcement thread for this for at least the next couple of days, and I'll try to answer any further questions in there as I have time. Thank you all for joining. Thank you for watching. Thank you so much for using the Unreal Engine. Please let us know when you're making cool things. Throw that out to us in the forums or tweet about it and let us know so that we can shout to the heavens when you make cool stuff. And with that, until next time, this has been another Unreal Engine training stream. We'll catch you on the next one.